Okay, what's up, guys? It took me quite a while to set up everything with OBS and shit. I'm just gonna start streaming on Twitch as well. So, yeah, it took me quite a while. I had few drop frames here and there, but I think we're good to go now. So, anyways, I decided that I should challenge myself, like, have a game development challenge for my own self and developing a simple game in one night. So, it's around 12:30 a.m. and I'm gonna start with, I don't know, just a game idea I had. It's pretty simple game. We'll see how it goes. The basic idea is that player collects what they want. They want score, they collect it. So I'm just calling it minimal run over here, and I set it up the basic project in 2D mode of Unity. I had some fun ideas here and there with the game. So we're just gonna start with menu first. So as soon as Unity opens, we're gonna start with the main menu first. I already have few scripts written for my own self, all like the game manager and stuff, the basic functionalities I perform with game manager. So I already have that down. We're just gonna import that stuff and copy paste it from my old projects. I'll explain it like how I use them and stuff. So anyways, I think Unity is good to go. Pretty much nothing over here. We just have our camera and it's in 2D mode, so obviously we don't see anything. And then in the game view, we just have a blank, display of the camera backdrop. So I'm just gonna go ahead and connect my Android device because this is going to be an Android game. And give me a sec, I need to find the cable. And we are plugged in. So one thing you're gonna notice is that I'm gonna use touch inputs. So I won't be, whenever I was checking the game, I won't be using this screen and clicking on the screen. Actually, I'll be playing the game on my Android device and you'll be seeing the output of the game over here. I'm just gonna go ahead and see if this works, because if it doesn't, then I'll have to restart Unity. Oh wait, it won't work. I need to switch the platforms first, dummy. So I'm just gonna switch to Android platform. It's gonna do a bunch of stuff. You gotta wait for it. And I think we're good to go now. So I'm gonna go ahead and close this. And okay, this is a good sign. This is like a very good sign. Can I at least test it? Yeah, I can test it, but I'm not able to see this on my Android device. So I'll have to restart Unity. Bear with me. This is like the most ridiculous part of Unity. I recently moved to Windows. I usually used to develop on Linux. And trust me, getting your Unity remote app to work with that was a pain in the ass for me. So let's go ahead and try now if it works. And nope, it doesn't. Let me go ahead and check the editor settings. Go to project settings, it's already there. Go to editor. You go to any device. Yeah, that's the issue then. Yeah, now I'm able to see it. So we're good to go with starting doing some stuff. Okay, so first things first, I'm just gonna go ahead on my main camera and go back to the inspector view, and we're gonna have a basic black background. I don't know why I lost my colors over there. But yeah, we're gonna have a basic black background, solid color obviously. So now it's pretty black, everything is black over here. Okay, so first things first, we're gonna rename our main menu scene. Can I actually rename it from here? Okay, so just a heads up, I am a Unity noob. We just started learning Unity, me and my friend, and we decided that it would be fun to develop games. So here we are, developing games, trying to give something good to the community. We have been gamers for quite a long time, but yeah, we decided that it would be fun if we were able to at least give something back to the gaming world. So yeah, here we are. So anyways, what I'm gonna go at is, um, I'm gonna create a basic main menu over here, so we can actually like start and have like a play button, the first screen which the player will basically see. So for that, what we're gonna do is we're gonna go ahead quickly, go to UI, make a canvas. So canvas is basically, a stuff where you draw your Unity UI stuff. So it's gonna be bigger than your game area. I'll explain what I mean by game area. So what all this white border selected rectangle you see, it's basically your canvas. So whatever you put in your UI, like say buttons or like say an image you want to user to see or any text, you should put them over here. Basically, the play button will come somewhere around here, and below we'll have a quit button, we'll have a settings button, and I think pretty much that's all we'll need. We might add leaderboards if we have enough time. So if I go back to the game view, you see again, we added canvas, but everything is pretty black because we basically just added a blank space where we want our buttons and stuff to be. So it's nothing much there right now. So what we're going to do next is we are going to check if I am dropping any frames. I am, but I think we should be good anyways. Okay, so getting back to the game, what I'm going to do over here is I'm going to go to my scene options. So the scene option is where you basically develop and place your objects and stuff like that. And by the game area, I meant this whole little small area. So let's just say that you want, to move the player. Let's just say if the player is a 3D character or a 2D character, you will add them over here and not in the canvas. The canvas is only for UI elements. I'm just gonna go ahead and see why am I dropping frames. I don't think it's my net, but I'll just need to check it. I'll pull out my stream and check how bad it is. Oops, I don't want to open the Rick stream. That was a close one. So I'm just gonna open Firefox, and we're going to go on my stream. There we are. Let me see how bad it is. I'm gonna do this. Let me see how bad it is. So I'm moving my mouse constantly to see how bad is the frame drop and how noticeable it is. Let me see how bad it is. So I'm moving my mouse. I guess it's not that bad. It's D-level. And if we go to advanced settings, does it say I'm fucked up? I guess I am fucked up, but what can we do? So I'm just gonna keep a new tab in case we need to Google anytime. Then we're going to get back and start with Unity. So we'll add a button element. Okay, where is it? There it is. So it had added a big button, and now if I go to my game scene, you can see the button over here. So we're going to go ahead and move the button down, like right around here. And I think it's a bit too down. I'm going to move it a bit up. I think this should be fine. Yeah, it seems fine. We're going to change the height and width of it anyways. So now we have added a button, and as you can see that there's already a text element as a child to button. So this text is basically what you want your button to say. So we're going to go ahead and change the text in the inspector and keep it play. And we're going to, it's already centered for us. And the font is Arial, so we're just gonna keep it that way. And I'm gonna do is I'm gonna click on the topmost corner, click Alt, and we're going to actually, I didn't mean to click the text, but I didn't mean to click the button. So I'm gonna scale button like a big and smaller in the width, and we're going to change the text size to something like 20, maybe 30. 30 should be fine. Now, how does it look? So it looks like this. So this is a big play button the player will see first. And I'm gonna rename my game object to play button. Sounds good that way. Okay, so that's our play button down. We're just gonna go ahead and duplicate it for the quit button. And I'm gonna rename it quit button. And I'm gonna go to the text, name it quit. So now we know that, damn the typos. So now user knows that this button actually quits the game. So we're gonna go ahead and move quit button down. So I'm gonna select the movement tool or the transform tool. We're gonna click on the green arrow, move it a bit down. Click on the button, just have a little bit more padding between them, and let's just see how it looks. So I think this is pretty much good. If we want to have a settings button, we can add it in between the play and quit. We can decide on that later. Yeah, so this pretty much seems good for a basic main menu. So we're gonna build on that later on as we add something which requires settings and stuff. Yeah, so let me just check on the drop frames. Okay, I don't think I'm dropping frames anymore, so yeah, that's pretty good. So yeah, so we have this pretty much down now, the quit button and the menu button. So what I'm gonna go ahead and do is I'm gonna create a new scene over here, and where's scene. Yeah, so there you go. Scene, and I'm gonna name this gameplay. So this is where actually the gameplay will happen. So we'll have all the player object and the stuff we want the game to be all over there. So the idea of my game is that we'll basically have let me just demonstrate to you over here. So the idea is that there will be objects falling from top, and the player will have to catch them. So the objects will basically be the amount of score. So let's just say that 100 number falling down, and player has to move like this and catch it. And if they catch it, they get 100 score. And now some negative stuff will also fall down. So let's just say there's a -1 life. Extra, like right after say 1,000 score point. So you gotta be quick, and just as soon as you catch the 1,000 score, you gotta move out of the way, otherwise you'll lose 1 life. So it's pretty basic game, and we'll increase the difficulty. So the difficulty by that, which means we'll just increase the speed of objects falling down from the top. So we are going to build a spawner on top and make a player catcher which the player controls. So I'm just gonna click undo to give my play button at the original position it was at. and we're going to save the scene just in case we didn't save it previously. We're going to get back to main menu scene when we add the functionality to play button. I want to do that after I make my gameplay. Essentially, what I do when making games is that the first thing I do is I make the gameplay, and then I jump back to my main menu and the game over UI. So we're gonna go ahead and jump on the gameplay scene. So as you can see, it's pretty much blank over here as well, and we have our camera over here, and everything is pretty blank. And as you can see, the background is blue again, so we'll change that to black over here, and we'll add the alpha as well. So now if you go to game preview, you see the pure black background. So that's pretty good. I mean, it's pretty minimalistic game, so we don't need any fancy backgrounds. But you could have fancy backgrounds, like, you know, like a skybox of moving space. There's this one game. I have a space background, so it moves around, it rotates, so you can go big homes with it. But for this game, we don't need to. So just in case what a skybox is, think of a cube. Like say your room. Now you're in the room, and if you see front, you see one wall. If you turn somewhere, like if you turn left 90 degrees, you see another wall. So basically a skybox is just that. I mean, your cube is a skybox for this particular camera. You are the camera in Unity, and if you look around your room, that's basically the skybox. The walls are the skybox. So pretty much a cube, and each face of the cube you can see is basically a texture which you want to be the sky or say background of your game at any given time. I mean, I think we'll have a separate tutorial for this when it is required, but the basic idea is just that the skybox is a cubical background, so that in a 3D world, if you move your face, you can see the background with respect to what side of the skybox is you're facing. That's pretty complicated, but I mean, just think of it as a real world example I gave earlier, that go to your center of the room, and you are the Unity's camera, and the wall of your rooms are skybox. Okay, so now what we're going to do over here is, first thing, I'm gonna jump back to my Inkscape. I have it open over here. So for those who don't know, Inkscape is just like a tool for your vector drawing, basically your drawings. So what we're going to do is we're going to make a player object which the player will control. So we're going to make the player. So I'm gonna go ahead and change my document settings over here. So document is basically the page size you want and stuff like that. So I'm gonna change everything to pixels first because that's more convenient to me. And we're going to say, I think 512 pixels would be enough. So we're gonna have a square, like a square area to draw, and we're going to have a checkered background. I'm gonna go ahead and close this. So I'm gonna zoom to my drawing space. I guess I can just do it from here. So yeah, so now we are zoomed into the workspace. Okay, so what I'm going to make is, first I'm gonna make a circle, a pretty ugly one at that, and I think we would want this to be around 60 pixels in radius, both top and bottom. I'm just gonna make it a 201. That's more convenient for me to resize in Unity. And what I'm going to do is I'm gonna change the fill color to, okay, I'm gonna change the fill color to transparent. You're gonna have like this, and I'm gonna change the stroke color, so basically the border, to white, completely white. And we might wanna make the border a bit thicker. like, I guess around 20 pixels. Let's see how the 20 pixels look. I might do 30. Yeah, this looks good. So essentially, what we are going to do is, since the player needs the objects to move about, I don't want player to be like, his thumb or his fingers exactly on the objects they want to move. So because that will obstruct their view and they won't be able to see the object which they want to move. So what I'm making over here is basically a circular area where I will make the player, hold the screen, or just keep touching this particular circle for them to drag the circle around the screen and move it. So what I'm gonna do, I'm gonna export this as a PNG file. Do I have the export tool open? I guess I should. Yeah, I do. So I'm just gonna export this to my desktop for now, and I'm gonna name it circle, or I should name it player holder. This sounds good. I'm gonna save it to desktop, and I'm going to make sure that it's exporting the selection, and I think we are Gucci. I'm gonna click on export. So now it should be here, and I'm gonna move it to my Unity. But before I move it to my Unity, what I like to do is I like to create a new assets folder, and I'll place this in textures. You can make it like the PNG or sprite. So I'm just gonna, sprite sounds better. You'll know why soon. So I'm gonna name it sprite. I think sprites should be more accurate. Okay, so I'm gonna go ahead, open my sprite, and I'm going to drag my 2D circle to Unity. And there we go, it's over there. Okay, so now we want user to be able to see this particular circle. So we're going to move it over here. And then I'm gonna make it like this. And as you can see, it has already imported the object over here as the name of player holder, and you can see its properties, you can see its sprite which it has chosen and stuff like that. So I'm gonna see how it looks like in the game screen, and I think it's too big, so I'm gonna decrease the scale of it and see how it looks. If I zoom in, does it look good? It looks pixely. I guess I'll make it smaller then. I'll make it like I'll make this like about 20 pixels. Let's see. Okay, I'm not resizing and just repositioning it. Yeah, now it's good. So I'm gonna make it like half the size, 100 pixel. And let me see if the Unity scale what was. So we use 0.5 scale, and it looks like this. I guess I might do it 0.2. Nope, that's too small. 0.4, let's see how it looks. 0.4. I will try this on my on my Android device as well to see how it actually looks on the screen. Yeah, it looks good. I mean, it's good enough to fit my thumb. All right, so okay, so I think 0.4 is good. So I'm just gonna go ahead back to my Inkscape, and I'm gonna change the radius to 80 all the way around, not 800. I meant 80. Where did my circle go? pressed backscape by accident. Yeah, now it's back. So just gonna confirm it's still 100. I'm gonna change it back to 80. Might go ahead and change the stroke style to 20 worth, and yeah, gonna export it again. Please tell me to export it in the right place. I don't want it to export there. I'll just change it again, and we name it player holder, so we override it and we export, and we want to replace. So there's our new player holder. We're going to do the same shit. We're going to keep it and drop it into Unity. We're going to delete the old one. We're going to check, and I think it needs a rename. Yeah. I'm going to rename it back to player holder. We're going to delete this one because this one doesn't exist anymore. Go back to scene and add this over here. Now it looks good. Okay. So the other thing which I want to make is the object which the player will control. So essentially what player will do is player will hold this circle down, or you can say this button down, and drag it about. I'll demonstrate it here. So he'll hold this down, he'll drag it about, and he'll drag it like this all over the place to collect the objects. And basically we'll have something like a rectangle, a small rectangle over here, which will actually be the object catcher, or you can say the player object. So we're going to go back and Inkscape, and we're going to delete our circle because we don't need it anymore. I'm going to select the rectangle tool and just have one simple rectangle down. And I think we might want to change the width to 100. And height to say 50. I guess I'll increase the width of it. I will increase the width. What should width be? I think 250 should be good. And for this fill color, we are going to have it completely white. There we go. So I'm gonna go ahead and, this is giving me OCD. I'm gonna go ahead and click on export as, go to desktop, and we are going to give it the name player rectangle. I'm gonna save it and export. And then we're gonna repeat. We're gonna go ahead and keep it over here, and then we're going to place it over here to see how big it looks. And we jump back to our game. So essentially this is okay. I mean, we could make this a bit more smaller, but I think we're gonna keep it this way for now, because there's a lot more stuff we have to do before we can go into like fine-tuning this stuff. So I'm gonna go ahead and see on my Android device again. So in case you're wondering how this is connected to the Android device, essentially Unity has an app called Unity Remote, which you can run and plug in and then play, and whatever you see in this game screen you see in your Android screen, and you can move about, like you can touch and it will detect those inputs and just translate it to the gameplay which you want. One more thing which we can do in the project settings in editor, you can see the resolution over here is downsize. So this basically like to reduce the lag between what's going on over here and what you're seeing in your Android device, and like how you're touching it and that being reverted back to your Unity. So basically Unity reading the inputs from Android device to reduce that delay, to make the memory a bit more easier. Basically Unity automatically downsizes the resolution, so you end up seeing like a very pixelated version of your game you can change this to normal, and when you click on play, then and you can see it would be a lot better than before. Okay, so this is pretty much the first part we want to do. Now here's one change I would like to make. So one change I would like to make is that right now my player holder and player rectangle are as two separate objects. So this is one separate thing and this is one separate thing. Now what I would prefer would be to merge them into one object. So I'm going to go ahead and create an empty game object over here. We're going to switch back to inspector and rename it player. Now what we're going to do is we're going to drag our player holder and player rectangle into player. Okay, so now you can see that we have our player over here, and if we move our player, we basically end up moving the player rectangle as well as the player holder. So why am I doing this is essentially I could have these two separated, but it would be hard to manage because then you'll have to make sure that the player rectangle follows the movements of player circle or player holder in our case. But now what we can do is we can just have the player move with the player holder. Essentially that's what we are going to achieve. So the whole screen, like the whole object moves together, and we don't need to take care of that the player rectangle moves in such a way that the distance or the position between them relative to them remains the same. Because otherwise what will happen is, if we don't manage it properly, what will happen is, say the player moves over here and the holder comes over here, but you'll have to take care that okay, this comes over here as well. So I'm gonna go ahead and undo everything so we move back to where we were, and I think we are fine. Alright, so that was a lot of talking. So essentially what we did over here, we created a player holder, we created a player rectangle, and we created a player object and told that the player basically has a player holder and a player rectangle. Alright, so I'm gonna go ahead and create a new folder for my scripts. In case you're wondering, I'm gonna work with C#. So in Unity you can also work with JavaScript. I prefer C#. And we're going to have a gameplay over here and a main menu over here. So basically all the main menu scripts will go in main menu and all the gameplay scripts will go in gameplay. Alright, so this looks good. We're going to now we want to have like movement down. The first thing I would do is master the movement. I had a pretty rough time with my first game for my movement, so I won't say I'm an expert now, but yeah, I mean I had a tough time dealing with it, and I guess I'm kinda good at it. So what we're going to do is we want the player to move when they touch the player holder. Okay, so what we're going to do is we're going to basically cast a ray to how do I explain it? Let me put it in a better way. So when the player touches the screen, he's essentially touching the screen, but Unity has its own world. So I'm just gonna zoom out to show you. Okay, so this could be anywhere in the world in Unity and you can see it on your screen. So essentially, unless and until it's in the camera, you'll be able to see it on your screen. If it's say outside of the camera and I go to game and see it's gone from here because the object is outside of the camera. So what we want to detect is when the player is touching the screen, we want to detect that he is touching the screen part area where this circle lies. Alright, so what we're going to do for that is we would want a way to detect that when does the player's thumb or finger collides or say coincides with our player holder over here. So for that, what we're going to do is we're going to like add a script. Before we add a script, we need to add a component over here, which will be a 2D collider, a circle collider to be exact. So if I zoom in quite a bit, you can see that there's a thin green line over here. Let me see if I can show it in a better way. If I disable sprite renderer, you can see this thin green line. This is essentially the area where the collision will be detected. So I'm gonna go ahead and tell you what this is actually means. So let's just say that I don't want it to deselect, so I'm gonna go ahead and enable sprite renderer again. So let's just say that this is a moving object, all right? And you want to detect when this object hits our player holder. If we do not add a 2D circle collider, this object will just pass through it like this. And you won't be able to detect when this object hit the circle. So to detect when an object hit a circle, you need to add colliders to it. Essentially, this will not work right now as well because there is no collider attached to rectangle. So the object will still pass through like this. But if we add a collider to this, you will see that this object will collide. I'm just going to display it quickly. We're going to have a box collider over here. If I disable sprite renderer, you can see there's a box collider. And to give it physics properties like weight and make it react to gravity, we add rigid body. And as you can see, there's gravity scale, there's mass to the object and stuff like that. So now if I hit play, you'll see this object fall down and hit the circle. And see, it's hit the circle, it's trying to balance itself on the circle. So essentially that's what a collider does. There's one more thing to the collider. If I go back to a placeholder and you see this is trigger collider. So say you want to detect when this object collided with the circle, but you don't want it to hit it physically. You just want to detect when this object is passing through the circle and or say going out of the circle, but not exactly make it hit. So for that, what you use is we basically use trigger colliders. Let me see, I undid a bit too much or not. Yeah, I don't. So for that, basically, you use the as trigger collider. So what this basically does is it changes your collider to a trigger instead of, say a physical body. So if I click on is trigger, this object will just pass through like it's not there, but I will be able to detect in scripts that when an object is entering the circle, when it is exiting the circle. So basically, if you just want to detect when an object is entering another object, you add an is trigger collider. So I'm just going to go ahead and quickly show you a demo. And as you can see, the object simply passes through, and you will be able to do something in your scripts when the object actually is passing through. I'll show you the methods which you can use because we will need those methods. So I'm gonna go ahead and I'm gonna keep the circle collider, keep the box collider on the rectangle. I'm gonna remove the rigid body for now and keep it as trigger. And just to double check, yeah, this is this trigger as well. So yeah, that's pretty good. It seems okay so far. Now what we're going to do is we're going to add a movement script to our placeholder. So we're going to name it player movement, and we're going to add the script. And it creates script folder over here, so we're going to move it to our gameplay. So essentially, for those who are wondering, script is just a line of code, or a computer programming file where you can write like what you want this object to do and stuff like that. So I'm gonna go ahead and open C# project. It's gonna open Visual C#. In the meantime, let me check the drop rate. Yeah, it's pretty good. It's 8.6%, so it's fine. It's gonna take a while to open up. I mean, I would really buy an SSD soon enough so we can reduce this time of opening items and stuff. Really, it's gonna take a while. And it's almost open. Come on, it shouldn't take this long. Yep, so it's open. So what we're going to do is we're going to open that script we made. Okay, so as you can see, there are already a few methods down here. There's an update method and there's a start method already in place. So essentially what start is, you can say when your game starts and this object is created, we basically the start script is called. So as you can see, the start is called before the first frame update. So essentially what this means is that when user will hit the play button, when the first frame will be rendered before this object is created, the start method will be called. So essentially the frame in which this object will be rendered, the first frame in which this object will be created, the start method will be called. The update method is called once per frame. So that basically means that with every frame this update method will be called. So you can say that, like how you hear that the games are running at 60 frames per second. So essentially that means that with each frame the update method is called. So that means in each second the update method is called 60 times. So you do have a few other updates, like there's fixed update. So essentially the difference between fixed update and update is, so the fixed update is generally used to calculate, do physics stuff, like, say if you want your body to have a force, like we want the circle to say have force to move up. So we will generally add that stuff in our our fixed update method, so it smooths out a bit. So why don't we add it in the update method is because that is not how Unity works, number one, and it's essentially very bad practice to have it over there, because let's just say that the physics calculation in Unity are a bit more CPU intensive. Having them like calculated with each frame really requires a lot of cost for the CPU, so it will affect that. It will affect your smoothness. and there's a lot more stuff to it. So essentially, you won't want your physics to have an update method because it will make the game jittery, a bit less smooth. It will be costly as well, and you want them in your fixed update and not in the update method. So fixed update is called every, instead of being called every frame, it's called after every certain amount of time. So what that certain amount of time is our fixed delta time in Unity. So I'm just gonna go ahead and open time window over here so we can see it. I don't remember where it is exactly. Let me see if I can find it. I'll open it for you guys to see. Is it in settings? Yeah, there it is. So as you can see, there's fixed time step, and there's maximum allowed time step, and time scale, and maximum particle time step. So ignore the 3 for now. These 3, just focus on fixed time step. So the fixed time step is essentially like after what time our fixed update will be called. So essentially, it's better to have your physics in fixed update to make things more smooth and more realistic, because then Unity calculates physics more and just updates the GUI accordingly, the frames accordingly. It's better to have it over here. All right, that was a lot of talking again. We're going to go back and get to the game now, because it's already a one game one night and it's 1 a.m. now, so I really gotta get going. Okay, so we added the script to our player holder. So what Unity does is the object to which you have added the script to, you already have an access to it. So if I go ahead and type over here game object, game object, and we're going to print its name. So to print anything in Unity, you can use debug.log, but generally make sure that you remove these debug statements later on when you're packaging the game or you're done with debugging, because you don't want them to be there and just print lots of stuff in background for when the game is launched and is installed on user's environment. So I'm gonna go ahead and save it, and we're going to log the name of it. So I'm gonna just click name, and we're going to run this scene. So Unity compiles the scripts, and all the errors in a script, you will see them in Unity. You will not see them in Visual C++ or whatever this thing is called. You'll not see them in Visual Studio. You'll see them in your Unity. So I'm gonna go ahead and click play, and I'm gonna show you the debug message in console. So you can see that the debug message is coming from what line? So it's coming from player movement script start method at line 10, and the method says placeholder. So if we see, we log the name of the object, we added the script to placeholder, and we get that particular name. So essentially what I'm trying to show you is that you already have the access to the object which you attach the script to. Do notice that you only have the access to that object in this script. If you wanted the object to be accessible from another scripts as well, there's another way for it, which we'll see. Pretty sure we'll see it soon enough. Let me just drink some water. I'm gonna have some water. I'm pretty thirsty. Alright, I think I'm good to go. Yeah. So what's the next thing which you want to do is we want to implement our player movement, right? So what we're going to do is we are going to say move our player whenever the user is touching it, and we are going to move our parent player. So we are going to this move, we want this movement when user is moving this, and we want the thumb to user's thumb to be followed. So we don't want it user taps everywhere and this directly goes over there. We want user to hold the circle and drag it like this. Okay, so let's get on with it. I was just checking if my stream is working fine. It's the first time I'm streaming actually. Yeah, guess what? Alright, so what we're going to do is we're going to make a boolean object. So to make that be a boolean, and we're gonna make it move. So essentially this is the name and this is the type. The type is bool for say true and false. We're gonna keep it false for default. You can skip this equal to false because default value of a boolean is false. I call it boolean because I'm using Java. I use Java at my work stuff, so I'm used to that, but essentially bool and boolean are the same thing. So what we'll do is we'll make this bool true. We'll make the move true whenever the player is holding our player holder. Okay. So now to detect the player holder, there are more than one ways to do it. Simple way would be I'm just gonna make it like I'm gonna have a camera over here. We're gonna make it public. So public means that this particular camera will be accessible to you everywhere in your project. But you'll have to get access to your player movement script first. So this is just core programming stuff. You should be already knowing it if you have already followed basic programming. If not, this is not the tutorial for it. So I will have tutorials down the line explaining programming, but for now it's not the scope of this particular stream or video. So the basic thing will be to do this. In our update method, we'll check for inputs. So we'll go ahead and if condition if input.get touch, input dot touches is greater than 0. So this means that at least one finger of the user is on screen. I need dot length of it. I don't remember the correct method. There was a better method. Touch count. There we go. Yeah. So this is basically making sure that at least one finger of the user is on the screen. And what we're going to do is we're going to get that touch, user's touch, and we're going to get the first touch that the user does. So essentially what this means that the first finger where the user touched the screen, that's what we care about. So let's just say that a user is touching say top left corner first, and then he also touches the bottom right corner. So with this method, with this thing, with input.getTouch0, we'll get the top left touch, not the bottom left. The bottom left touch, if you want the bottom left touch, we'll get it by changing this to 1. But since we only care about one touch, the first touch the user did, we're going to keep it to 0. Okay. So now there's a bit of this. Try to understand this. Like, remember how I mentioned that Unity has his own world? So essentially, this is the whole Unity world, and user will basically see whatever there is on the camera, right? On a screen. So the user is not directly interacting with the Unity world. User is touching the screen, and the points on the screen may be different in your Unity world. Like, say for example, if you just look at the position of our player, it says 0.13, 0.14, and 0.2. So this is the Unity position, right? When the user touches the screen, he's actually touching the screen. And so basically, you know how screens have pixels, like how 2160 cross 1080. So these pixels are basically just, points in your lengthwise and your widthwise. And when you touch, you get the point according to your length. So let's just say that if a user touches over here, you get 0, 0. If a user touches over here, you'll get something like 100 cross 200. So that means that you're 100 above height and you're, say, 200 across your width, and you're touching over here. Kind of like a graph system, if you ever done it that in math. So like how you to donate a point at any area in the graph, you essentially just get its y and x coordinates. So essentially that's what's going on over here. The key thing to understand and note over here is that when the user touches over here, he'll get something like 100, 200 point. But in Unity, you can see it's 0, 0, 0. Oh, close enough. So how do we actually convert the touch point to the Unity's world? Well, it's pretty simple. So remember I have this camera over here. I'm gonna change it to cam because Unity stuff. And there's this method called cam.screen to world point. So essentially what it does, this method will take your screen point, so essentially the place where you touched in your screen, and convert it into Unity's world point. So essentially when the user touches over here, Unity will take that point off the screen from the Android operating system and convert it into the Unity's world point. So the 100 cross 200 will be converted into 0, 0, 0 over here using this method. So now I'm gonna go ahead and get user's touch position. So to do that, you simply go check user's touch position. And there we go. So now we have the user's touch position, and we're gonna just check that, and we're gonna store it. We're gonna store it in vector. Touch pos should be good enough. Okay, so we have our touch position now, and for now we're going to make the move true, so you can see what's going on over here and what are we doing wrong. We're gonna go if move. We are going to go ahead and move our game object. The lar method basically just accepts 2 input and changes the first one to your next one. So we're gonna give it, like, you're gonna change the object's transform. So essentially the object's transform position, and you're gonna make it to we're going to have this actually as a global variable, so we can access that in our fixed update. Touch position, and we are going to give it a time dot delta time. So this is basically, you want this parameter for smoothness, and you want the multiplying parameter is basically increasing the speed of it. So we're gonna keep it 20. So it's gonna be pretty fast actually. We're gonna keep it 2. And we want the changed stuff to go back to our position. So essentially what's going on over here is we're using a vector3.lerp method, linear interpolation method, to change game object's transform positions, player holder's transform position, get it near to our touch position, and with this much speed. So this will give us a vector 3, which will be a bit more nearer to touch position than the previous position of our game object, and we're going to assign it back to our game object. So we can see that the object will essentially move. So I'm gonna go ahead and just show you a demo of how it's looking at for now. It's still popping up in Unity. I need to pause and play it again. Okay, so if I touch anywhere, okay, there are errors. Let me see why. So it says the cam variable is not assigned. So that's because I have made a camera over here, but it's not assigned to anything yet. So what we can do is we're going to go in and placeholder script. Now you can see that the cam variable which I created is over here. So we're just gonna drop it over here. Essentially, anything you make public will be visible over here by that name. So you can just drag and drop and assign it. So when you run it, it's already assigned in the at the runtime, and you can see the output. Okay, so nothing is going on. It's not moving. Let me see why. So it's not moving because I guess this is coming out to be 0. So to debug, I'm just gonna quickly go debug log input dot touch count. Let's see how it goes now. Yeah, so you can see it moved a bit and then now it's gone. So where is our object? It's right here, but you cannot see it. You cannot see it because if you notice, the camera's Z is -10 and your player's is -9. So this is pretty much very bad. We're going to make it 0. And it's -9 again, so it's changing for some reason. We don't want it to change. We might need to do some of the tweaks over there because we don't want this to change. Otherwise it will become invisible, because let me just show you. If I do Z -9, well, it still stays, so it's something else that's causing the issue. This is basically general issues which you have while putting down controls. The first thing is it's automatically moving to top. That's because we have moved true, and the touch position is essentially initialized to 0, 0, 0. So it moves it to 0, 0, 0. Gonna go ahead and click play. If I touch, you can see the touch count becomes 1, but again, it just goes away. So we gotta fix this bug, because this is one nasty bug. Let me see what could we do to fix it. This is pretty much good. Why is this -9? I want this to be 0. And that's pretty much it. And if I go over here, I might want to make this vector 2 instead of vector 3. It should take care of it now. Because vector 3 is when you work with 3D, X, Y, and Z, but vector 2 is essentially what's required because we are working with 2D. Let's just see if it works this way now. Okay, I'm moving it and it stays. So yeah, it's moving fine, but now you will see the issue. If I touch here, it comes here. If I touch here, it comes here. If I touch here, it comes here. It's not like draggy. So right now I am dragging it, so it's kind of following my thumb. And now I'm lifting up and I'm gonna go and touch the top right corner and it instantly comes there. So there's no obligation for a player to first touch the holder and only then they'll be able to move. So that's why this particular thing is not a good thing to do in this case. This is fine when you want, just player to follow taps or something like that. Or you want to, check where the player is tapping. It's fine for that, but not for other stuff. So for that, what we're going to do, we're going to cast a ray, basically. You can think of like a laser beam from your camera to the point where screen is being touched, and that laser beam is going to detect what's in the way, and the first thing in the way it will return as the first thing in the way, and then we'll be able to see what it's touching. So essentially you can think of it that the laser beam goes down like this, and then we get that. Okay, it's what the actual thing is, that is the player is touching. So to do that, we do have another method in our cam point. Cam dot screen to point ray, I guess that's one thing which we could do. Or there's another way to do it. The ray cost. We want a ray cost hit 2D first. Hit. So this will give us the object hit, and you want a ray cost 2D. Physics, I think it's in physics. Physics 2D dot ray cost. I hate Visual Studio, it never gives me documentation. Okay, so physics ray cost, the origin would be camera's position, so cam dot transform dot position. The next thing it requires is the direction. So you cannot just give the touch position over here. So we still need the previous thing which we did. We need to get the world point from our touch position. And now we need the direction from it. So to get direction between two vectors, you just simply subtract them. That's how I do it. Vector 2 direction equal to Let me just be sure that's the correct way to do it. I have a movement script. I mean, I guess I told you guys I am new to Unity, so I don't remember all this stuff back of my head. It's just one of the challenge I took to develop a game in one night. Where's the gameplay? Where's these scripts? There we go. Gameplay. We're going to go with wormhole. We're gonna open it. Okay, this one's not it. I guess it's drag controls. Yep, it's this one. So we got a touch, we checked the touch phase. Yeah, I was doing the correct thing, almost. Well, you can skip the direction, I guess. I did skip the direction in the previous one, so why not this one? So we have the touch position, so we're gonna go with touch pause, and we're going to say the direction would be what could be the direction? I guess the direction could be the direction we need is downwards, so we're gonna try vector 2.0. This should work essentially. Yep, this should work as well. We're going to give it raycast. Damn it, give me raycast hit 2D. Thank you. Hit. I'm just gonna go ahead and copy paste this. That would be easier. I just want this to touch, pause, and we want this to change to cam. What's wrong with this? Okay, we want this whole thing to change to touch pause actually. And why is this causing issues? Oh, I need to do this 2D. Wait, why is this causing issues again? Physics 2D, I'm dumb. Duh. I can't even copy paste stuff right. I don't know why. Yep, I found the issue, and it was because of this. And we don't need this. So hit basically returns us the object that was hit by the ray, or you can say the first object that the laser beam touched. So we are going to check if hit is not equal to null. So essentially, the object actually hit something, and hit dot collider. Am I doing this correctly? And yep, I am. Hit dot collider. I'm gonna change this to hit collider. In case you're wondering, collider is essentially the collider which we added to the object. So this will basically return us the collider, not the game object. We're going to check if game object dot name was our player holder. So if yes, we're going to make our move true. So now what's going to happen is move is going to be false by default, and when the player touches, we're going to cast a laser beam from camera to player to the touch position. And we're going to check if the touch position was player holder. If yes, we're gonna move. If not, we're not. So I'm gonna have an else over here. Move blue false. Okay, so let's check if this works. I highly doubt it would, but why not? So it does work, but it's very, very, very slow. Why? Because we have the metal lerp over here. So right now I am touching and I am moving very slowly. If I touch anywhere else and I move, it won't move. Right now I am rubbing the screen like crazy, it won't move. Okay, so now we're gonna go back and we're going to fix this. So what we're going to do is we're going to check what was the phase of the touch. If it was user's touch just began, so that's just that. This is the moment when user will, he has just touched the screen. So if the user's touch phase began, we want to check if the user just touched the player holder. If yes, we're gonna move. If not, we're not gonna move. And we're going to check else if the touch phase was ended. This is basically, when the user lifts up the screen, we're gonna stop moving. And what we're going to do is, as soon as the move is true, instead of lerp, we're gonna try what happens if we assign the touch position. So let's go and find out. Let it compile. Even I hit play, and first things first, touching everywhere on the screen, it doesn't move. Next, okay, it moves for a bit, but not anymore. So it's essentially like if I am touching at the edges of the circle, it's moving. So I'm not able to drag it for now. So we're gonna see why is that case. So that's because as soon as you drag your finger out of the circle, the ray, we're still casting the ray. So what happens is that the next ray which is casted is outside of their player holder. So it doesn't detect that it hit the player holder. So it makes move false. So we can't go ahead and just remove this now because we have a way for move to go false when the user lifts the touch. The move will only be true when user has actually touched a player holder, and as soon as he lifts the touch, it will become false. So now it should be fine. I'm just a sloppy programmer. I learn by my mistakes. And this is another one of them because I still can't, do anything. it's still the same. So we're going to go ahead and see why. We're going to need some logs, because what's essentially going on is that it's not getting updated. This thing is not getting updated, and that's wrong. So what we're going to do is we're going to make it sure that the move remains true and it doesn't fucks up. If I'm sure I'm correct. Okay, what could be the issue? Or there would be the issue over here is the move is becoming false. So where is the move becoming false? Is it becoming here? Because the only logical reason to this is that the movement is becoming false, and that's why it just stops updating our movement. So I'm gonna go ahead and debug stuff. There's another way to debug. You can have a breakpoint over here, and you can attach it to Unity so that whenever you hit play, and the code comes at your breakpoint, it pauses, and you can then run line by line so you can see what's actually happening. But we're gonna keep it this way. I'm touching the screen, and the movement is now false. I'm touching the screen. It's not becoming false. The issue is completely something else. And the issue is that I was dumb enough to not add this. So we are detecting users touch, begin, users touch, end, but we are not detecting users touch phase in case user has moved. So we need to detect that as well. So that's what happens. I mean, this is pretty much something I know, but I'm dumb, and what can I say? I mean, this should have been over there already. If move is true, we're going to update the touch position. Because if move is not true, we don't need a new touch position, because it's not gonna move anyways. So now, as you can see, it's following my player as fast as I move. So as I'm touching the thumb now, I am moving it about, and it's moving. It's following my thumb. I left it. It's not moving anymore. If I touch anywhere on the screen, it's not moving the object at all. So touch, move, don't touch, don't move. Touch anywhere else, won't move. So this solves our movement problem, right? Nope, it doesn't. We wanted our rectangle to move with our circle. So that's why we made this as a parent. So what we're going to do is we're going to move our parent instead of our circle. And we're going to see how it looks. So over here, we would want to get parent instead of our child, and we are going to move that. So the easy way to do this will be we just make a public game object. go back to Unity. And we go back to our player rectangle, player holder. Okay, I'm gonna wait till it sees there's an error. Error is over here. So we're gonna go ahead and comment it for now. Go ahead here, go back here, wait for it to compile, go back to player, and attach our player. There's a way you can get parent, but I don't want to get involved in it. I just want to keep this game simple. And we're going to go ahead and player.transform that position, go to touch position. I'm gonna go ahead and save this. You're gonna go play. You're gonna have to wait. Play. And it's moving everything. But so there is this one issue right now with this. So I'm touching the circle, and as you can see, it instantly moves back. It instantly moves back. It's almost as if the circle was not even there, and I move it up, it's now coming up. Now, so if I am touching the circle, as soon as I touch the circle, it will move down, and there will be like a good gap between my thumb and the circle. So now my thumb is actually not on the circle, but it's still moving because I was touching the circle before. So why is this issue happening? I'm gonna go ahead and see where my player is. My player is over here, and my thumb is over here. So as you can see, the player center is here, and the holder placeholder center is here. So this is essentially what's causing this issue, because we won't want that. Now what's happening is I touch my thumb and it brings the player center to my touch position. I don't mean I touch my thumb, I mean I touch my placeholder. As soon as I touch my placeholder, the player position goes to the touch position. So what's happening over there is, as soon as I touch, this moves down a bit like this, and then because I'm still moving, I go into touch phase.move, and I'm able to move it like this. So that's essentially the issue over there. It's a simple fix. We can just move our player holder to the center of the player, so they coincide with each other. And we're going to move this also at the center first. We're going to move this also at the center. So now that everything is at the center, we're going to go down, and now we're going to start placing it much better. We want our player holder to be at the center now. So instead of moving player holder anywhere, I am going to move the rectangle a bit up. We're going to try, say 2. 2 is 2 up, 1. How about 0.8? 0.8 sounds good. So let's just see if this issue persists now. I'm on my top. Wow. I'm on the circle, and I am able to move it fast. And as you can see, as soon as I touch, it just moves a bit. It doesn't move too much. I'm sorry. And I can't move up. So that's my player movement. Now the next part. Now what we want is to spawn objects from top and fall down like this. So what we're going to do is we're going to make an object spawner, and the object spawner's job will be to spawn scores. So before that, I am going to make some scores which I would like to see. So I'm going to go ahead and have a text box over here, and I'm going to give it center alignment. God, I'm trying to figure out where's the center alignment. Aligned right, it's aligned center already. It doesn't seem center aligned. Okay. So first score, we are going to give it 100, and we want the text to be white. So the first score, we are going to have 101, and we are going to make sure that it's a perfect fit. That's it. Also, we might increase the font size a bit. Let's just try font size a bit more. I want to increase the font size. I'm not able to find it. Am I blind? Yeah, there we go. So we're going to increase the font size to 40, maybe a bit more. 56. Is this a font stuff? I think a bit more wouldn't do any harm. I think this should be fine. Also, any cool fonts? Nope, no cool fonts. We're gonna keep it Arial then. Let me just see how it looks over in Unity. Gonna select, and we're going to export it on desktop. We're gonna name it 100 score. Go back, get it. Oh, where did it go? Oh, I didn't export it. Export, go back. 100. And we are going to get it back here. How my stream doing? Oh, my stream is doing pretty good. Oh, okay, so it directly added over there. We wanted it to be in textures. Sorry, sprites. So we're gonna go and drag it again. And we are now in sprites. So let's just see how it looks. So I think it's big enough for user to see the 100 score and actually collect it. So I guess we're doing a pretty good job right now. So what we're going to do now is we're going to make an object spawner. So I'm going to go ahead and what did I delete? I'm going to go ahead and delete this, and we are going to create an empty one. Object spawner. I'm going to name it object spawner. So this object spawner's job will be to spawn scores, spawn, like negative lives and one-ups and stuff like that. And we would want this objects to be spawned outside of the screen, because imagine like the player would want to see this thing coming down from here, and not like it spawns right here and then moves down. That will look ugly. So we want it to go like this, not like spawn and this, because that will be like ugly for player. So what we're going to do is I'm going to move my object spawner in center again. I'm going to move it up out of my screen. So create empty objects. You cannot see the empty objects, but you can use them in your scripts and stuff like that. So now my object is pretty much in a good place. So I'll spawn the scores around here somewhere, just to be enough in the screen, and we should be good. So I'm going to attach a script to my spawner. I'm gonna name it spawner script. So the script will spawn everything. Spawner. And before I do anything in the script, I'm going to move it to gameplay. Okay, so it's in the gameplay now, and what we want is, I'm gonna delete this one. What we want is it to spawn this 100 score. So we go ahead in our spawner. So first we need to have that 100 score over here. I'm gonna create a public game object over here, name it 100 score sprite. What's the issue? Okay, oh my god. Score sprite 100. That should be good. Okay, so now what we're going to do, we're going to jump back in Unity. We're going to click on object spawner, and we're going to attach this. I'm pretty sure we should be able to attach prefabs. Okay, so I dumbed out again. So this is basically an image right now. What we want is this to be in sprite. So I guess I should do it in a bit better way, but it's fine. I'm gonna create a new folder over here and call it prefabs. So prefabs is essentially a template of game object which you saved. I'll show you what I mean in just a second. So what we want is our 100 score to be here. So now it's essentially a game object with a sprite renderer, not an image, right? So now since this is a game object, as you can see, I will be able to drag and drop this over here, but we won't want this one because as soon as this is destroyed and deleted from memory, we'll lose access to this. So we want this to, you know, stay in memory, because essentially when, let's just say, player catches it or it moves down, we will delete this object. So we will not have it over here anymore. So we want this object to be with us at all times. So what we are going to do is we're going to go back in our prefabs folder. We're going to drag and drop this. So now it's our game object, which consists of a sprite renderer, or basically an image renderer, and our image is 100 score. I'm gonna delete it, and now I'm gonna go to object spawner and I'm gonna attach my prefab to it. So essentially the times you want prefab is if you want something to spawn again and again, if you want to use something across the scenes, you want to prefab it, and then you can just use it in your whole project anywhere you require by attaching them into the script, or just dragging and dropping like this. And you can edit prefabs in Unity. Let's just say if I say edit the position of anything, I go to overrides, it will tell me that there are some changes I can overwrite all. I can select individually which changes I want to go to. I'll show you in a bit later what I mean. One other thing you can do is you can open prefab. You can edit stuff from here too. Alright, so now that we have object spawner, the 100 score, we won't see it instantiated over here. We need to manually instantiate it first. So we are going to go do just that. So for that, we have a method called instantiate. And we're going to instantiate a score sprite 100, and we are giving it the position now, so we're just going to give it transform. So essentially the transform is basically the transform of the object spawner right now, so it will spawn it in the same place as the object spawner, and we're going to give it 0 rotation. Quaternion is how Unity does its rotation stuff. We're just gonna say that We don't need any rotation. Why is this fucking up now? Okay, it needs a position, not a transform, right? So I need to add the dot position over here. So this is essentially the position where our 100 score sprite will be spawned, and with 0 rotation. Let me just show you what it does. I'm just gonna quickly start and stop it. So as you can see, it created so many 100 scores at the position of the object spawner. So you can see the object spawner and 100 clone both coincide. And if I go into my game screen, I don't see them right now, but now they're there. So the first thing which we'll fix is it's spawning buttload of 100 scores. I'm going to have a spawn interval over here. So first thing, we're going to create a float. Float is basically a decimal number. Spawn interval, and you're going to tell it that you spawn everything every 0.8, or you can say 1 second for now. And we are going to have previous spawn time. We're gonna have it 0 first, and whenever you want to get the time, the current time of the game running, you use time.time. So this returns you the total amount of time, so from the start of the game to the current frame that is being rendered. So let's just say if you have you have been running this game for 10 seconds, this will return you 10 seconds, wherever you call it. So what we're going to do is, as soon as the gameplay starts, we want the first spawn to happen after, say, 3 seconds. So what we're going to do is we're going to go previous spawn time equals to time plus 3. So essentially this is just setting our previous spawn time to 3 seconds. And in our instantiate, we are going to check if our time.time becomes greater than our previous spawn time, you spawn an object. So essentially this is just checking that as soon as our time.time becomes greater, I think I should change the name to next spawn time instead of previous. That would be more accurate. I don't know why I named it previous spawn time. So essentially what this does is it checks if our time is now more than our next spawn time, you spawn the object. And so now we want to update our next spawn time to 0.5 seconds after this has been spawned. So we're gonna go time.time to spawn time interval. So basically, let's just say that we started the game at 10 seconds. So after 3 seconds, time.time will be greater than next spawn time, that is 13 seconds. So when the time.time will be 14 seconds, it will spawn a 100 score. Then it will add it will change the next spawn time to time.time plus spawn interval. So time.time is 14, spawn interval is 1. So this becomes 15 now. So when this time.time will become, say, 15.1, this becomes greater again, and then it will spawn again. So that's how essentially it works. To make it exactly, we're going to make it equal to. So now it's like it won't wait for 15.1, but as soon as time.time is 15, and because next spawn is also 15, so it's equal, so this will spawn. So now if we go ahead and run instead of buttload, we'll see like one being spawned each second. So first will spawn after 3 seconds, and each second 100 score will be spawned. Okay, so now this spawns right at the center, and if they move down, they will be right over here. So we want to introduce some randomness to the spawn points. So first thing, we are going to check the width of our like the area we can play around with. So I'm gonna go ahead and move this down. I'm gonna see that we have 3 to 3. So essentially, if you see the X, we can go from -3 to +3. I'm gonna just go ahead and move it back up. So we can go random between -3 to 3. So if we go back to Unity, what I'm going to do is I have a vector 3, vector 2, I guess. Spawn position, transform dot position, and we're going to generate our random X. For a -3 to 3. And actually we're going to make it an integer. Int. Now there's one issue with it. Since we have our -3 to 3, essentially we'll have the center of the game object at -3. So it'll be like this. Now if you go into the game view, you'll see that 100 is cut off. We don't want that. We want 100 to show completely. So I'm gonna go ahead and zoom it a bit, and we're going to move it like this. I think that's it. So essentially what we have to work around is 2.7 to -2.7. I'm just gonna go ahead and make it 2.5f to 2.5f. F means slope, by the way, and we're gonna change it back to float. So this way, it never ever generates a 3 or anything greater than 2.5, so that it doesn't touches outside of the circle, or any digits go outside of your camera. And now we're going to change our spawn positions X to our randomly generated X. What happened? You don't have a Y? Am I making a typo? I am making a typo. I hate typos. These are the worst ones. Alright, so now we have a spawn position, and instead of transform position, I'm gonna make it to spawn pos. Okay, so if I now delete this and I'll play it, you will see a bunch of spawns at random places. I'm gonna go ahead and zoom out so we can actually see. So see, now it's spawning a bit randomly at each second rate. Okay, so now what we want is we want these to move down. So moving down is essentially the property of a 100 score. So I'm gonna go ahead and add a script to 100 score, and I'm gonna name it obstacle behavior. Not obstacle, actually. Collectible behavior should be a good thing, because essentially we'll have more collectibles than just a 100 score. So a collectible behavior would be a good way to do it. Now we want each of the collectible to go down. So what we're going to do is we're going to we are going to make it go down a uniform rate, and we are going to then destroy it after it moves out of our screen. So to move it down, there are actually a lot of ways you can do. You can modify transform.position at each frame, so you can go do something like this: transform dot position. You can go like vector2 pause transform dot position. You can do this, and then you can just go that po dot y minus equal to 0.1, and then you can just go ahead and transform dot position equal to say po. So if I go ahead and run this now, there's an error. Let me check. I'm missing a semicolon. So you can see that these are going down, 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 but these are not getting destroyed. And also they don't look quite smooth. So what we're going to do is, to make it more smooth, we are going to remove this. One thing which we could do is we could delete this, and we could just add it to a void fixed update like this. And then let's just see how much difference does it make. 1, 2, 3. So it's a bit smoother, but not too much. You could decrease the 0.1 to 0.5 to make it even more smoother, but I don't want to get into that stuff. I just want it to go down in a good way. So what we're going to do is we're going to just remove this, and we're going to go back in our prefab. Open prefab. We're going to add a rigid body to it. We're going to remove the gravity scale 0 so that it does not affect gravity. We're going to also add a collider to it, a box collider to be exact, so we can detect when the player hits 100 score. We're going to make it is trigger, because we want this 100 score to pass through player instead of going hitting player and just staying on his on the rectangle. We don't want that. We're gonna click on, just make sure it's saved, and we're going to go back to our scene, go back to our script. Now we have rigid body attached to it, and we would do is we would do a game object dot get component, so to get that rigid body 2D. So now we have the access to rigid body 2D, and since rigid body 2D handles the physics stuff, we have velocity in it. We're gonna add velocity to 0 on x-axis and 1 on y. So let's see how it looks, or even if it works or not. Stream is pretty brilliant now. If I go to scene, they're moving in the opposite direction. Yeah, that's great. So what we want to do is we want to move the -1 outward, also increase the speed a bit. As soon as one spawns, it will come down. So I think this is good for a basic slower difficulty, and we might want to increase the spawn interval for that, but I think this is pretty much good for now. Alright, so I'm gonna make this public vector 2 move speed and we're going to assign it move speed, and we're going to go back in our spawner, and we're actually going to convert this into a method, and we're going to say this as void spawn simple 100 collectible or score. And what we're going to do is we're going to copy paste it over here, and we're going to call this method over here. So similarly, we can just quickly make a 200 score. I'm just gonna quickly export it to desktop. 200 score, save, export, make sure Unity is in the correct folder, sprites, get it to sprites, make a game object out of it, focus on it by pressing F or double click, add a collider to it, and then we are going to go to prefabs, make this a oh wait, I need to do this as trigger, make this a prefab, I'm sorry for that, I meant to say it, and delete it. And now what we're going to do is we're going to make our game object as score collectibles, and we're going to convert this into array. So now we have 2 collectibles, and we're going to change this to score collectibles 1 0. You'll get why I'm changing this, and as soon as it compiles it will show me the array of score collectibles. Since we have 2, I'm going to say 2, and the element 0 will be our 100 score, element 2 will be our 200 score, and we will copy paste this method, and we will change this to 200 score. We will make this to 1, element 1 is 200, and now we will do some fancy stuff. We will change this. We'll basically govern what to spawn by by randomness. Yeah, that was what I was looking for. And we don't need actually this method. We're just gonna name it spawn simple score. We're gonna have an int index, and what we're going to do is you're gonna make an int. Actually, we need to make it. We can just call this function quickly. Spawn simple score random dot range between 0 to 2. So there's this one difference Unity has. When you are getting an int, random.range will return int, and it will not include this. So it will basically randomize between 0 and 1, not 2. But if you were to say get a float over here, it would random between 0 and 2, so it will include 2. So that's what you have to keep in mind. So it will like 0.1, 0.2, 0.3, 1.1, and then it might give you 2. But if you are getting an integer, it will only give you 0 and 1, not 2. It won't give you 2. It won't ever give you 2. So that's one thing which you have to keep in mind. So anyways, to make it more simplified, I'm gonna make it score collectibles dot length. So score collectibles length is 2, so it will always give me between 0 and 1. Okay, so now if we go back and run this, you'll see that our collectibles spawn and they don't move down for some reason. I'll see why these don't move down. So we're gonna go back, we're gonna see why these don't move down. Because, oh yeah, I remember now. We made this public, right? So we need to change the velocities. And now I forgot this to do for 200 score as well. So I'm gonna do it for 200 as well. I'm gonna add the collectible behavior script to it. And we're gonna give it a minus 2.5. It's more score, not 2.5. 2.1 should be good. A bit more faster, just a tiny bit more faster than 100 score. Spawn 100 score, move down, move down, move down, move down. Please spawn a 200, please spawn a 200. Why the fuck are you not spawning a 200? Come on, go, go, go. My god, it's not spawning a 200. It's not spawning a 200. Okay, at this point I believe there's an issue. It should be able to spawn 200. Oh, it won't spawn 200 because I need to change this to index. I'm dumb. I am just plain and pure dumb. Now it should work. 100, 100, 200. There we go. And 200, 200. Okay, 200s are not coming down because they lack a rigid body. There must be an error, yeah. So there are a buttload of errors that 200 component is keep not having the rigid body. So we're gonna go ahead and add the rigid body to it. Here we go. Obviously gravity to mass to 1, gravity to 0. And we should be Gucci. So if you notice, 200 is just a bit faster than our 100 score. Alright, so now that we have a way to move, a way to spawn scores, collectibles, we are going to make more stuff. I just want to change one thing. I would want to change the spawn interval to 3 seconds each. Okay, so now what we're going to do is we're going to make sure that player catches the score and they disappear. Now, if you go to our prefab for 100 score, you can see that the collider is triggered, and same for 200 score. You can see that the collider is this trigger. So that basically means that these 200 and 100 scores will not physically collide with the rectangle, but instead just pass through it. Doesn't matter if the rectangle is triggered or not. We're just gonna go ahead and make the rectangle is triggered too. It's already is triggered, so that's good. And this is also is triggered, so that's also good. So now what we're going to do is we're going to make sure that this particular when the 100 score or 200 score collides with our player rectangle, player receives something. So first things first, we're going to make player rectangle script behavior script. I'm just gonna move these to gameplay. I'm gonna go back and we're gonna go there and player rectangle script. So remember I told you that to detect collisions you have methods. If your collider is not is trigger, you have on collision enter, which detects the start of collision, and on collision exit, which detects the exit of collision, on stay collision, on particle collision. So you have lots of stuff. So for trigger, we have on trigger enter and on trigger exit and so on. So on trigger enter, so basically as soon as the 100 score touches our rectangle, we want it to do something. So for now, we're just gonna debug.log. To get the game object, we're gonna give other. So other is basically the collider. This needs to be 2D, not 2D. If it's 3D, it's need to be on trigger enter. If it's 2D, it's need to be on trigger enter 2D. And by the way, by 2D, 3D, I mean the colliders, not the game. If your collider is in 3D, you need on trigger enter. If your collider is, say, circle collider 2D, something like which has 2D in it, it needs on trigger enter 2D. Other.gameObject.me. So now I'm gonna go ahead and just quickly run this. And I'm gonna move player and actually catch some stuff. And I'm gonna go ahead and console. As soon as I catch, you'll see, okay, I should collapse this. So now you can see, I catch 100, it prints 100 score. I catch 100, it prints 100 score. I catch 100, it prints 100 score. If you see the count of the score of the print is increasing. So now the 200 score, now the 100 score. So essentially I am basically catching this stuff. Alright, so now there is one issue with this. If as soon as player collects the score and moves back, he can still collect it again. So this is basically a bug. To fix this, there are two ways. If you still want the score, to keep going down in collectible behavior, you could make a boolean called bool collected equal to false. So it's not collected right now, and you want to make public so you can change it from somewhere else. And as soon as in the player behavior script, you can actually go like this, get component, and for the component you want the script, so you will get collectible behavior. You can set the collected to true, and in an if condition you can check if the collected was false, then go here, otherwise just skip it. So it will only collect once. But essentially what I want to do over here is I want the game object to be destroyed, the score to be destroyed before it leaves the player. So I'm gonna go ahead and call on trigger exit 2D, and I'm gonna go, and this needs to be private. I'm gonna go ahead and destroy our collider, our collision game object. I don't understand one thing. For this it gave me other, but for this it gave me the collision, so it's kind of dumb. I wasn't on trigger enter 2D, right? Yeah. Okay. So now what should happen is as soon as the score starts exiting, it should get destroyed. And as you can see, it gets destroyed. So basically we are simulating that, okay, the player has actually collected the score. Okay, so I think that's pretty good. I mean, we could go ahead and change the methods. Like we could destroy it as soon as the player touches, or so like as soon as the on trigger enter happens, we could destroy it there and then. That could be one way of doing it as well. You can just choose any way which feels convenient to you, or you can even go crazy and you can go like on collision stay and do something like more intense. So anyways, this is one way of doing it. I'm gonna keep it that way. We're gonna update score soon on the basis of what score is collected. So I'm gonna go ahead and in the collectible, I'm gonna check if it's has a score value. I'm gonna have it public an integer score value. By default, it should be 0. We're gonna go ahead and update it in our prefabs as well. And score value is 100. In 200 score, it's 200, and we Gucci. I'm gonna get some more water. My throat is drying up, kinda. How long have I been streaming for? It then shows the uptime. Well, I don't know how long I've been streaming for. Who cares? Okay, so now, where was I? If a player misses the score, it reaches down below and it will just keep going down and down and down and down and down. So we don't want that. We want, at some point you want this to be destroyed, because let's just say player misses too much of scores and just keep going down and down and they don't get destroyed. And as a result, what happens is that your game gets buttload of objects spawned and they're not destroying, it's consuming memory. So essentially, it's a memory leak. You use up quite a bit of RAM till the game crashes. So what we're going to do is, in our collectible behavior, we are going to check if transform dot position dot y is lower than some amount, destroy it. To find some amount, what I'm going to go do is I'm gonna move my player down. So I'm just gonna destroy it when it's -7. So if my object reaches below screen and below -7, it gets destroyed. Let's just see how it works. We go to scene to view what's going on behind the scenes. It's spawn, it's going. Okay, it's going, and it's get destroyed. As you can see, the number of object decreases. So that's actually a good practice to follow. And I'm just gonna check if it's still working. Okay, my on trigger enter for the score 200 it's not working, but for score 100 it is. There is some kind of an issue for score 200. Why is it not working? It says trigger, it should be fine. Oh god, I'm feeling sleepy. I should not feel sleepy. In our flare rectangle behavior, we are destroying everything, and this is there. This should work fine as fuck. I don't know why it's not working fine. If we do debug.log, what does it say? And for now, we are only going to spawn 200 score. I guess it's because of this. Is the edge radius of this 200? Nope, it's 0. This should be 0 too. I'm sorry, I really had to sneeze over there. Spawns a 200 score and move it, it gets destroyed. So yeah, that was the case. Basically, I gave the edge too much radius, and it was kind of going. Basically, the collider would become very small in this case. Alright, just give me a sec, I need to do something. Sorry if it's causing disturbances. I need to watch my guy streaming. I miss him. Alright, so we are ready to go. Yeah, so we are good to go. Okay, so what I was doing was we fixed this 200 issue. Why this 200 was not getting destroyed, and now we also did the objects getting destroyed when they move out of the screen. The next thing which we are going to do is we're going to display the score. So to display the score, we will need a UI. So we will add a canvas first, because everything in UI goes in canvas. And for my canvas, I'm gonna say scale factor. I think this should be fine. Constant pixel size. Scale with screen size. No. Match screen mode, width or height. And we are going to keep it at 0.5. I don't do the UIs generally, my guy does them for me. But yeah, I mean, for now, I just know the basics of it. Okay, so for the UI, we're going to have a text. I'm going to name it score text. We're going to see, we're going to change it to white. We are going to, okay, we're not going to keep it white, it's too whitey. We're going to keep it something like green. Let me just increase the size a bit. Center it and like this. 200. And I'm gonna increase the size to 50. Let's see how it looks. I guess it's too big. 40, 30. 30 should be good. 35. Yeah, 35 should be fine. And we are going to place it down below. Since we're placing it down below, we'll move it here. A bit padding to this. And these are basically anchors. So these require to be positioned correctly for resizing when, different screens. So since we want this to be positioned with respect to bottom left, a bit towards the right from it, we're going to change it to bottom left. So if you want something positioned to be top left, you change the anchor to top left, top middle, from center, you change it to center. So that's a good way to, give the correct position across different screen sizes. Okay, so now what we can do is we can update the score value. So for that, what I'm going to do is I'm going to make I could do it in more than one ways. For now, I am going to do it in a fairly simple way. Oh wait, I should just show you the correct way, the way which I use in my games. What I do is I create an empty object. I name this gameplay manager. And I make it static. So to make it static, I'm just gonna copy paste the code I already have. I just open with any stuff. Okay, I'm gonna copy everything over here. Okay, actually, this is a pretty simple code. I don't need to go into complicated coding. Actually, I wanted to make it singleton so that I can access it from anywhere instead of having it to create and go through the headache of, like making sure that it exists and stuff like that. It's generally a good practice to make your game managers singleton. Adding a script to it. Singleton basically means that at any given time, there can only be one object for this particular script, or you can say game object in this case. We are going to make a public, not public, we're going to have an integer score, which is going to start from 0. And we are going to have a method for public void update. Oh my god, I didn't mean to fix update. Public void update score. We're gonna give it value. Okay, so we're going to get the name of the game object over here. Or we could just get the game object over here. Alright, and remember we had this score value to our collectible. What we're going to do is we're going to update the score with the score value. So int score value equal to obj.getComponent collectible behavior dot score value, and we're going to do score plus equal to score value. So now we have the score value updated, but it won't show in the UI as of now because, I mean, we are just updating an integer variable over here, but we want this text to be updated with this. So we're going to go ahead and add an using script, and we're just gonna tell C# that we're going to use Unity engine. God, I fucked up. Unity engine .ui, and we're going to make it text, public text, score text. And what we're going to do is, when the score is updated, we are going to set the text of the score. Score text dot text equal to score dot toString, and we want this as a normal number, not as a scientific number, so we're going to give an n0 for it. Otherwise, when the score gets too big, it will show like 2. Let's just say score is 2 bazillion, it will show you 2 into 10 to the power 10 or something like that. But we don't want that, so we are going to keep it like this. And since we have our score update placed, we are going to, from the canvas, we're going to attach the gameplay manager score object to this one, and we are going to set the score text default value to 0. Just gonna make sure it's big enough. And I think I made it too big. I think this should be fine. Let me just see how much numbers it can incorporate. Yeah, it's big enough. It's definitely big enough. Okay, so now what we want is to call our update score method from the collision. In our player rectangle, I will call gameplay manager's update score. So for first things before, I need to make sure that this is a static instance. So what we're going to do is gameplay I'm gonna set a game object instance. At start, we're going to do instance equal to this. Sorry, game object. If instance equal to null, instance equal to the game object, and we are going to have a get instance method. No, why it returns me game object. Get instance and it returns me the instance. So I'm a bit confused whether we make it game object or we make it this script. So I'm just gonna go ahead and confirm that. Okay, so instead of that, we make it this. So I'm gonna make it this as well. So this will basically directly give me the script. Why I was being confused is because if we keep game object, then we get the game object and not the script. But we actually need this script. So we can call this method. If I were to get the game object, so the gameplay manager game object, I would have to do get component gameplay manager script, and then I would be able to use it. But I don't want that. I want directly the script gameplay manager. We're here in our collider of the player rectangle behavior. We're going to create a gameplay manager equal to gameplay manager equal to gameplay manager dot get instance. I need to make that static actually. Where is it? The instance. Okay, here it is. I'm blind. Static. Public static. So if it's static, we don't need the object to call it. Hey, this should be fine. Why is it causing an error? Does not contain, it's a typo. It's a typo over here. Yeah. Okay, so now that I have the instance, I can just quickly call gameplay manager dot update score, pass it the game object. Now the score should be updated each time I collect. See 200, 200, 400, another 600, 700, 800, 1000, and then 1200, and so on. So the score is down. Alright, I'm just gonna go ahead and switch back to all the spawner to make sure that it spawns 100 as well. Alright, so now that we have our spawner ready to go, what we're going to do is we're going to make a life, a -1 life, like basically an object which will give -1 life for a player. So say player has 3 lives, if he collects that, he'll get -1 life. And what we're going to do is for that, we are going to make sure that we have our Inkscape going in that. Alright, a -1. I color it red. So I'll show you a neat little trick with this one. I'll write -1. I'll export as to desktop. Now I need to change the name of it to -1 life. I guess -1 life should be saved. I don't think Windows lets us start with minus, but let me just check. Okay, that's safe. I am going to go back to sprites, import it there, make a game object out of it, add a collider 2D to it. Let me just see where it is. Is it too small? Nah, it's Gucci. Alright, so now the neat little trick I was going to show you is that I want this to be red, and one way to change the color would be to change it in Inkscape. The other would be to keep it white in Inkscape and change it from here. So it's now red. So this will make the player lose life. I need to add rigid body 2D to it too, to make sure it gets the velocity. Need to make sure that gravity scale is 0. Then we can go ahead and add it in our prefabs. And you can see the -1 is red. We can delete it. I need to add collectible behavior to it. So I'll show you that how we can save stuff. So I'm gonna keep the score value to 0, and it doesn't matter. This will be -2. And in the override script, I'm going to apply all. So now all the changes will reflect to the prefab which we just created as well. So basically it's just save the changes I made to this game object to the prefab of the game object. Delete this. We're gonna go ahead and now, so this would be basically an obstacle for a player which he has to dodge. So we're going to, in our spawner, make a public game object obstacles, because we might want to add some more, like, you know, -2 life or game over. So player rectangle, and what we're going to do is, oh sorry, I want to go to spawner. We're going to go and add one obstacle. I'm gonna change this to this. Okay, so now that we spawn items every second or so, I want to make sure that sometimes, probably say 5% of the times, we spawn an obstacle, or you can say 10% of the times we will spawn an obstacle when spawning, you know, a simple score. And to add to a bit more difficulty, we could do this randomly as well, but to add to more difficulty, we can do something like, you know, right after score. So basically these spawns look something like this. So there's 100 score. Okay, I need to go here. So it looks something like this. So there's 100 score, and right before it, there is a -1 life. So the player has to quickly collect and get out of there. Otherwise, the -1 life will be his punishment. So what we're going to do is, first things first, we are going to have a int chance spawn obstacle, and we're going to get random.range between 0 to 100, and what we're going to do is, if that chance of spawning is less than, say, 30, so there's 30% chance we spawn an obstacle. And so what change I'm going to make over here is, since I need to know where my collectible has spawned, so that I can spawn right after it, I'm gonna make the spawn position as a parameter. And I'm gonna copy my spawn position logic to here, and we're gonna change this to spawn position, and we're going to just pass the spawn position now to here. So now basically I have my spawn position to you know, spawn my punishment, or you can say obstacle, above my score. And before I spawn the obstacle, I would like the score to spawn, just in case. I mean, I should do things in order. Okay, random range, not random range. Random dot range, bro. Okay, so spawn chance is less than 30%. We spawn an obstacle, and to do that, I'm just gonna go ahead and copy this. And instead of spawn score collectibles, we are going to use obstacles index. I'm gonna name it simple spawn, simple obstacle. So why I'm naming these simple, because you might want some complex stuff, like, you know, spawn left to right moving score. So like 100 score moves left to right like this. So might want stuff like that. So for that, you might want to create a new method, and you might also want to, add like a new script, left to right movement to each of your collectibles. Keep it disabled by default, and then enable it. And for your knowledge, just to enable a script, you can go like game object.get component. Say move left, right is your script name. You can go ahead and .enable equal to true. So this will enable a script and start moving your object left to right. Alright, then now what we're going to do is we're going to copy the random logic for index. Oh my god, I should sleep. We're gonna copy this. Yeah, I was looking. Oh my god, I was looking for this. We're gonna copy this, and instead of spawn simple score, we're going to call spawn simple obstacle. And instead of spawn collectibles, we are going to use obstacles. Is there a typo? There is. Obstacles. Is there a typo over here too? Obstacles. Spawn simple obstacles. Yeah, my god, I'm bad at typing right now. Obstacle. So now, since we changed the variable name, we need to go back to Unity and change it again. So this is one of the issues. I mean, there is one way to solve. You can just type it editor.renameable. So it displays a different name over here, but it's just better. I mean, whenever you change the name of a game object, you just come back here, make sure that it's still there. If not, just add it. Okay, so now that's done, and we are good to go for our -1 thing. So one thing which we would like to do is we could do it like this. We could make it so that we can add a life detect value over here, and we can just do the same way we do with the score. We can update score in that way as well. So now what I'm gonna do is public int life value. So essentially this will give player some life. By default it's 0. And what I'm gonna do is gonna go back here, give it life value of -1. So it takes away life from player. Another thing which I'm going to do is give player a life system. So I'm gonna go back here, go in player rectangle, give him lives in public. Should I keep this public? I guess I could do without public. In lives equal to. So by default he has 3 lives, and if life hits to 0, we are dead. So now what we want to do is we want to check if player has hit a life or a score. So I'm going to show you a good way to do this. We can tag our game objects. So I'm going to go ahead and add a couple of tags. I'm going to add a score tag, I should change. I mean, it's fine. We can rename it later on. And I'm gonna add a life collectible. So now I have two tags, core and life collectible, and I'm gonna tag this as life collectible, tag this as a score, and tag this as a score. So now what I'm gonna do is I'm gonna go back here and check for the tag of my game object. So what I'm gonna do is I'm gonna get my game object here, collided object equal to other dot game object, and what I'm gonna do is I'm gonna check if other dot game object dot compare tag, if the tag is score, you update the score. You update the score, and else if I'm writing else if because we might want to check out for other tags later on. If you can do other.compare tag already, then it's pretty good. But I'm just gonna do it other.gameObject tag anyways, because I know that's the way how it works always. I don't want to get into this right now that if the collider works or not. That will make me look dumb if it doesn't work. And I say that you could do this, but you cannot, and then compare tag life collectible. Is this the right spelling for it? COLECTIBLE. Yeah. If it's life collectible, then what we're going to do is instead of going to game object, we could directly we have to make some changes over here. We want those lives to be decreased, right? So what we're going to do is we are going to decrease the lives first, and for that we are going to need our collectible behavior script. Actually, we can just get the value and life value equal to other dot get game object dot get component collectible behavior life value lives plus equal to life value. So now for if it's say a player punishment like -1 life, we get -1 over here, minus plus becomes minus, so -1, so this becomes 3, sorry 2. If it's a 1-up, then we get a 1-up, 1 plus 1 over here, we get 1 plus 1, 3 plus 1 is 4. So this basically will handle both a punishment, say an obstacle hit, a -1 life, and as well as a +1 life. And for ending the game, we might check as well. Right now, lives is equal to 0. So as soon as the lives become 0, it's GG. Oh, it's 3:17 a.m. and the game's still not done. It's taking quite long. I thought I would be over by now. And now we go back to our scene. I'm gonna make sure everything's okay with pointer. Yeah, oh my god, I'm missing one thing. So we want this to spawn right above our score, right? So we will have to change our spawn position first. Spawn position dot y No, y has to go plus some amount. So for some amount, I'm just gonna go in and check once. And if they spawn at the same place, oh, roughly at the same place, how much up it needs to go. Okay, I guess there should be a better way to do this. I'm gonna give this as a 1 position. Gonna keep this as 1. Now I'm gonna move it up. So it needs to be roughly point. I'm gonna make it a bit easier for player. I'm gonna make it 0.7 of a difference. I can delete it. So plus equal to 0.7f. Should be good. Yeah, it's working as it's supposed to. It's almost far enough. It's getting hit by player. And I'll just have 1 more life now. And you can see that it printed GG right there, which means that the game is over. But the player won't know that the game is over, and the player doesn't know how many lives he has left. So how do we display life to player? I had a pretty creative way for it. So at the start of the game, we could display him, say a greenish color, green, and then 4 lives is blue, and then something like this, something like this. So we have this. Green is you have 3 lives, you're good, and so yellow is you have 2 lives, red is this is your last life, then cyan should be like this is your 4th life, blue is your 5th life. So I'm just gonna keep it very green. So gonna decrease the blue to 0, green to 1, and 1. So this is our start color. I'm just gonna go ahead and have these colors in our player rectangle behavior, because that's where we will be changing them according to the lives. So we want our colors. Color of green equal to new color, and you're going to have it R is 0, G is 1, 0, 1. In case you're wondering why I'm not doing it in 255, 2550, you could do that as well, but that's a 32-bit format, I guess. And how to get these 101's numbers, you can just go in and go on your color selector and RGB 01.0 and this one. You can see there are hexadecimal codes over here as well to copy paste and stuff. So now we're going to have our yellow. So for 255 representation, you gotta go into 32-bit. And for yellow, we are going to make it, the color would be this. Okay, so 110 should be fine. 1 is red, 1 is green, blue is 0, alpha is 1. Alpha is transparency. And we have our red equal to new color, which really simply 1, 0, 0, and we have 1 over here. And also what we could do is for our cyan color, zero, 1, 1. Zero, 1, 1, 1. And for our dark blue, we keep it 0, 0, 1, 1. Okay, so for starting, since the color will be green, we'll keep it green in start, and we will change it the color where the lives change, so over here. Okay, so now what we do is this is our sprite, right? We have our sprite renderer attached to the player rectangle, of which the color we can change. Just gonna keep it green over here. And so that's the component which we're going to get. We're going to keep it like sprite renderer, so we don't need to get it every time. And at the start time, we're going to set the sprite renderer to GameObject.get component sprite renderer, and we're going to do sprite renderer dot color equal to green. So at the start of the gameplay, or the game, basically, you'll see green. And over here, else if lives equal to no, we're gonna start with 5, I guess. If we have 5 lives, sprite renderer dot color will be dark blue. I'm just gonna copy paste it. Five, we have 4, 3, 2, 1. 4 will be cyan. 3 would be go back to green. 2 would be yellow. 1 would be red, and 0 would be basically you're dead. So we don't need to do anything over there. We could do some color, but it's okay for now. Alright, so now if I save it and we run this, we should be able to see these changes in effect. Pretty cool way to show life, I thought. I mean, why not? I'm not spawning life for now. Okay. See, the color changed to yellow. And now it will change to red. Boom. So this is my last life, and now I am dead. Okay. Pretty easy. And to make sure that a player sees a game over and a score, we're going to make a game over screen now. So to make a game over screen, I'm gonna make a panel, and I'm gonna keep it transparent so that right now it changes our gameplay. Yeah, actually that looks good background. I might change that. I might make the background gray instead of black. For anyways, I wanna make the transparent, and let's just try gray background. And this looks nice. I'm gonna keep this for now. So anyways, going back to it, the panel is basically where you can keep your UI stuff grouped together. So I'm just gonna keep this as gameplay panel. And I'm gonna make another panel called game over panel. Where the fuck is it? UI panel game over panel. I don't mind having this a bit of a background-ish. I mean, let me see how it looks. Yeah, it's fine. And in game over panel, we would want to show players score. And current score text. We're gonna have another text over here somewhere, which will be, oh, I don't need it in the panel, the text duplicated, which will be our score. Then actually we can do this in one go. We don't need this. We need another one for personal best text. And what we're going to do is move the score up, personal best a bit more up, go back to here, increase their sizes. I should not duplicate this right now, actually. I should duplicate this later on. And the center line, the font could be 40, normal. Let me see how much numbers it displays. Pretty big enough, it should be good. A bit more up. Let me see how it looks. Actually, we need to move this a bit down. We'll duplicate this. You add this as a game over text. Game over. Move this up. Actually make this more wider. Bigger to 60, 70. And bold. Yeah, that's all. That should be good. And red. I'm gonna add an exclamation mark. current score will be here. We duplicate it, move this a bit down. This would be personal best text, and this is giving me OCD. I'm gonna change this to personal best. So you just know by looking at what's going to be displayed where. You are going to have a few buttons. Button. We're going to have a few buttons over here. We're gonna make this button look thick. The text would say restart 30. Restart button. There will be another button right below it. I think this should be fine. This would be our quit button, sorry, main menu button, and the text would say main menu. Oops. That should be fine. If we go to our game, we see our restart, we see our main menu, we see our personal best score, but we also see our, this score. So, but if I disable this, and you can see the score goes away, but the game over still stays. So what we're going to do is, by default, game over panel will be gone, gameplay panel will stay on, and when the game's over, we will display game over panel, and we will do that in our gameplay manager. And for that, we go over here, we go to our gameplay manager, we will have two panel references. I'm gonna keep it panel. We should keep it game object public actually. Game object, game over panel, and a gameplay panel. And since game over panel also has scores to keep track of, score text and stuff, we'll also add that to it. Game over score text, personal best text. Okay, so now let me just see if the stream's still going Gucci. Yeah, it's still going good. Okay, now what we have to do is we're gonna make a function called game over. And in this, we are going to disable our gameplay panel. That's how I disable it, and we're going to name it our game over panel. Okay, so now that the player is dead, we want the player movement to be stopped, and to do that, we can do it's okay if we keep it on actually for now. I mean, we could just have an instance of player older over here and just disable the script just like we did. I showed you, like you can just get component player movement and then dot enable equal to false. Actually, I might just do it anyways. I won't be lazy. Public game object, and we're going to player holder, and when the game's over, that's when the life's equal to 0. I'm okay. This is giving me OCD now. Five, 4, 3, 2, 1, 0. Looks good. And over here, we're gonna say player holder dot get component player movement and dot enabled equal to false. So the player won't be able to move anymore. Okay. Now we gotta call this game over function. So when the game's over, we get the gameplay manager dot get instance dot game over. Okay, so now the game's over and we will show the game over panel. But before, we want to make sure that the game over score text is correct. So I'm just gonna go ahead and make it like this. We're gonna make the personal best text later when we actually save the data. Okay, so we're going to do a game over score text dot text equal to score dot to string and 0. So now this will set the correct text for our game over panel. Let's just see how it all plays together. $200, you're gonna go -1, 500, 600, we're gonna go -1 with this one to check game over panel, and we're gonna go -1 with this one. Okay, so it caused an issue because I forgot to assign the scripts. God, I am an idiot. We are going to go to game manager first, assign everything here, then we're going to assign texts, game over, this one actually, we need to assign personal score text to score text and personal to personal. That should be done, and color rectangle should have an instance of player holder. Yeah, now it should work. Last life, and we die. We can see that our personal best was whatever, our score was this. You can go return our main menu. So it's looking pretty good. The only thing is that the object spawner keeps going. So one thing which we could have done over here is we could have, instead of having our placeholder script here and then disabling it from here, we can do it in our game manager script. Why? Because essentially we will be calling the game over function every time the game is over from anywhere. So it's better to handle all your game over stuff in one unified place instead of having many places, because then you'll have to change a lot of places if you want to change something at the time of game over. So we're going to change this here, and we're going to have our object spawner here too. We're going to have object spawner too, and we're going to disable our spawner script too. We could essentially just destroy the objects as well, and it should be fine that way as well. So spawner got enabled false. Go back there in Unity, and we go to gameplay manager. We add our stuff to it. Okay, so now we won't see those objects going down and down and down and down and down. And we would see the spawned ones going down, but after that it won't spawn anymore. One more, -1 life. Hasn't spawned yet, hasn't spawned yet. Come on, spawned. Okay, now I die. We're gonna see a bit of them going below, and that's all. Actually, I might just destroy these game objects anyways, but it's okay, it's fine. We can see, we can see what's better. We can destroy object spawner, and we can keep the player holder the way it is. Anyways, let's just move on to other stuff now. So I guess we can call the gameplay complete over here, because if you say you want to add more stuff, you want to add 1-up life, you have a way, or you want to spawn any object, you have a way, you know how to do that. So it's pretty good over there. I'm gonna just quickly go ahead and go through a difficulty increase logic. So for difficulty increasing, what I would want is, I would love if my spawn interval would be decreasing. Sorry for that. My spawn interval decreasing, so more objects spawn. Or I would like more obstacles to spawn. So I'm gonna change some names over here. I'm gonna give spawn obstacle and keep a integer here, and obstacle spawn chance gonna be 31st. And now we change this to spawn obstacle chance. It's the different obstacle spawn chance. So actually I'm going to keep it to 10 first. And we are going to change the difficulty. So we're gonna follow the same rule. After every 10 seconds. You can do this, by the way, you can do this with a score too. You can just track the score over here as well. And the way you could do it is, one way would be doing it would be, you get your text of the score text and you convert it into an integer, and then you can check what's the score value, and you can check it that way. So it could be score based as well, or you can just get the gameplay manager and you can make this public, or you can make a get score function that gives you score. You can get the instance of gameplay manager here, you can get the score, and you can compare it that way as well, whichever seems fit. We're going to increase difficulty every 10 seconds. And next, increase time equal to, it's going to be 0 for now. We're going to have next increase time equal to time plus 10. Yeah, 10. Now we're going to define our max difficulty parameters. So our max difficulty parameters would be max spawn time interval, actually minimum spawn time interval. Min spawn interval will be 1.2 f, and then max obstacle spawn chance would be, say, 60. So what do we do now is we make a method called increase difficulty. There we go. Why is this showing an error? Already contains a method? What? Oh, increase difficulty interval. Okay, then now we are going to increase difficulty. We are going to do this if spawn interval is greater than minimum spawn interval. We're going to do spawn interval minus equal to 0.2f. So basically, each time the difficulty increases, the spawn interval is decreased by 0.2. We could make it 0.3 to be more effective, but for now we're gonna keep it this way. And say if our spawn interval goes less than our minimum spawn interval, we're just gonna be sure and check spawn interval set to minimum spawn interval. We're gonna follow the same procedure for our obstacle spawn chance. If obstacle spawn chance is less than max obstacle spawn chance, because we actually want to increase the obstacle spawn chance, we increase obstacle spawn chance by say I guess 4 should be fine, by 4%. So it's gonna be 14, then 18, then up to 60. And if, let's just say, if it's becoming more than that, we just make it sure that spawn obstacle chance is equal to max spawn obstacle chance. Hey, what the fuck? Okay, this should be int. I can just make it over here. Int. And now we're going to check if it's max difficulty. If spawn interval equal to minimum spawn interval and our obstacle spawn chance equal to the int value of max obstacle spawn chance. If that's the case, then we are at max difficulty. Okay, so we're gonna make a boolean called max difficulty. And we are only going to do all this if we are not at max difficulty. Actually, we don't need to check this over here. We're going to, in our update method, if time is greater than or equal to next increase time, this should be increase difficulty. We're gonna change it later. And we are not at max difficulty. We increase difficulty. So this will just increase the spawn chance and the rate of spawning of obstacles and the rate of spawning of the collectibles per second. So as you progress, you get more obstacles and you get more scores. So essentially, it will become like you have to dodge every 1/4 every 60 obstacles out of 100. That's the objective. If it seems too much, you can tweak it later on. You can just change it to any lines. I mean, I'm just going up by the wind over here. One thing which you can also do is you can calculate how much time will it take to increase your difficulty. So let's just say we are at 30, right? And we can go at 60. So we need 30 more increases, right? So how many times, how many iterations would it take for us to reach 30? So that will be around 6-7 times. So every 10 to 70 seconds. We'll need about 7 to 8. We'll need 8 seconds for us to reach max difficulty, as if we go by our obstacle chance, and if we go by our spawn interval, we need to go to 3 to 1.2. So basically, we are going down by just a second. I need to do something. I need to do quick math. I'm very weak at it. Actually, I'm just kidding. I need to drink water. So, as I was saying, so we gotta go from 3 to 1.2. So we are basically going down 1.8. So 0.2 divided by 1.8 is 9. So that's 9 iterations. So 9 iterations means 90 seconds. So a total to reach max difficulty would take 90 seconds. So that's how you can essentially see and tweak about how you want to increase difficulty. If you think it's too long, you can increase this amount, or you can just decrease this one. I'm just gonna go ahead and decrease my minimum uh, obstacle increase interval to 5. So now it's like 45 seconds to go to max difficulty, and yeah, 45 seconds to go to max difficulty. You can change it to 8 and stuff like that. So yeah, that's the way you can have a difficulty engine. So now the game will go harder and harder with time. Okay, so that's the difficulty engine in place, and it would work fine. If you want to see, we can just keep the difficulty interval time at 2 seconds or so. I guess it's fine. I guess I can show it to you by playing it for a bit. Gonna hit play. I'm just gonna notice that how much less number of times will -1 spawn now. So it's spawned now, and then it might spawn again. Okay, so the difficulty increased, difficulty is keeping on increasing, and we die. So as you can see, the spawn interval is quite a lot less now. It's spawning a lot more frequently, and you can notice over here as well, it's spawning frequently. It will keep on increasing. Why is the object spawner not disabled? That's my other question. Is the player holder also enabled? So player movement are disabled, but for spawner it won't disable. I have no idea why. Just gonna quickly check it. No, because I didn't save it. I'm dumb. And did I assign object spawner to it? Yeah, I did, but I didn't save it, so maybe that was the case. Anyway, we have this in place now, and now the last critical thing which we are going to learn is the game manager. So essentially, whenever you want to navigate between scenes, transfer some data from one scene to another, like say you have n number of levels, like instead of having an endless spawning system, you have levels, and you want your score to transfer over to next scene. Or so let's say you have another gameplay after, like once the player wins, there's a whole different gameplay he has to do, and you want your score to transfer from this scene to another. Because your gameplay manager right now, it won't persist between two scenes. For that, you can just set it to make sure that it do not destroy on load, and then let's just so you can transfer scenes the data between one another. So the score will persist across the scenes as well, and the gameplay manager will not get destroyed after your scene changes. So essentially, whenever you want your scene, some object to stay in scenes, you would want them to say "do not destroy and load," so that whenever you change the scene, or let's just say they go from main menu scene to gameplay scene, that object stays intact. So we use gameplay managers typically for managing gameplay, but to manage the whole game, we use game managers. So game managers essentially are, it's a script, nothing fancy. It's just a script which creates a game object that will not get destroyed whenever the scene is changed. So I'm gonna go ahead and create a script. So as you can see, they have even a special icon for it. So I'm gonna copy the static code for my game manager. It's easier for me that way. Where did it go? Is it in assets? Yeah, it's here. And we are going to copy everything in our get instance. Actually, I will just copy this whole thing. I'll just copy this whole thing, and not the whole thing actually. I'll just copy whatever is required, and then we can go from there. So first we'll copy this. We'll copy all this. You're gonna go start game, quit game, restart game, go to menu, get score. Get score, we don't need get score. I really want to make this game quickly. It's getting late for me. Okay, so first things first, we're gonna need to make an instance. Game manager instance. I'm gonna go ahead and delete audio manager because we don't need it right now. And this should be static. And we don't need Unity apps right now. So I'm gonna go ahead and comment it. I'm gonna comment this as well. No need for the audio manager right now. That's my dog. He's making his bed. So essentially what this script does is, for now, it just loads one scene to, it just navigates you from one scene to another, and essentially it does one more job. It gets the audio manager, which I made for the other game, and it plays the music related to it. So for example, if you're going to menu, it plays the game, it fades out the gameplay music, it fades in the game menu music. Alright, so now what we're going to do is, I'm missing an import, so I'm going to get that first, and then I'm going to explain you what it is. I mean, I'm not going to explain you guys, I'm going to explain it to you guys. Okay, so the scene manager is basically a Unity class which helps you load scene. So for example, over here, I loaded the game over scene because in my game I had game over as a whole different scene to do a bunch of cool stuff like showing a score counter. So score starts from 0 to count and counts it till you reach your max score. So that's kind of stuff. It's not needed over here, but just to show you that there's this one way to load scenes. You can do scene manager .load scene, the name of the scene. That's one way. And then there's scene manager load scene and integer. So what is this integer? This integer is essentially the order of which the scenes are added in this build settings. Yeah. So right now there's no scene added. So I'm gonna go add scene. Actually, I don't want a gameplay scene. I'm gonna add another scene in there, and that's going to be my main menu scene, and my main menu scene should be the 0. So this 0, 1 is essentially what the integer should be corresponding to change scenes. So it's pretty much good. We're good over here. We just added scenes. We created our game manager script. In our game manager script, to make it static, we created a new game object by the name this, and we added this particular game manager script to it, and we took it instance. We make sure it does not destroy us on whenever a new scene is being loaded, so our game object is not destroyed. And we do this in function call of get instance. We check if instance was null, that means no game manager was created. We will create one and then we'll return it. Okay, so that's that, and now we are going to make way to go from our main menu scene to our gameplay scene to our main menu scene. So remember we made button main menu. We're going to add a listener to it. So what we're going to do is we're going to go to our gameplay manager script. You can do this in another script. You can make a script like for on your canvas. You can attach a script like canvas button listener, and you can make whatever I'm making over there as well. But for now, I'm just gonna quickly make it in our game manager. We're gonna make gameplay manager. Sorry, we're gonna make on main menu clicked, and what we're going to do is we're gonna call our game manager dot get instance. We're gonna go to menu. This should be void because you don't want to return anything. And if say player clicks on restart click, you can name it tabbed as well. Clicked is because you basically click a button. So yeah. Okay, so on restart click, we want to go ahead and call game manager dot get instance. So now we want to go to restart game. Let me just be sure that these integers are correct. So in go to menu, we're going to 0 scene. In restart game, we are just loading the first scene again. Yeah, it's fine. So on restart click, we just restart the game. Okay, so that's that. I'm gonna quickly make the pause as well. So for that, I'm gonna import the pause UI button for me in our sprites, and I'm gonna show you how to change the icon as well. So I'm gonna quickly go to my assets and UI. There's a pause button over here. There it is. There's a pause button here. I import it here. Say bye bye to you. I make in our gameplay panel, I add a new button. Where it is. UI. I add a new button. Call it pause button. Pause button. Move it up. I need my mouse. Move it up like right here ish. We don't need the text, so I'm gonna delete the text. And I'm here. I am going to go to my sprite. I'm gonna choose the pause sprite, and we're going to make it look good now. I'm gonna go here, I'm gonna click and click Alt. This seems enough. This should be good. Is it too big? It's fine. Could be a little short, but it's fine. And that's all for the pause button. We're gonna make a pause panel. Where it is, UI. Panel, pause panel, And we're just gonna quickly copy a button, place it here, copy it times 2. We're gonna name it to resume button, change the text to resume and move it up. That looks weird. Is the text fine? It's fine for now. And we rename it to restart in case the player wants to restart again. And the text is fine for this one. We name it main menu in case the player wants to go to main menu. Change text, main menu, and your Gucci, we just move this down a bit. Another text, the button. Is it because of something else? Yeah, it's because of the enter. So now we have our pause buttons in place, and we're gonna disable the pause panel by default. It's gonna enable when the user clicks pause button. So in our game manager, we'll add listeners for this as well. Public wide on pause clicked. So when you want to pause the game, the simplest way to do it is you use time.timescale equal to 0. Think of timescale as the rate of flow of time in Unity. So 1 means normal, that means our 1 second is equal to Unity's 1 second. So if you do it 0.5, it means our 1 second is equal to Unity's 0.5 seconds. So it's basically half amount slower. And if it's 0, our 1 second means Unity's 0 seconds. So it's just not gonna update anything because essentially everything is called on time scale. Okay, so on pause clicked, we're gonna do this. On public wide on resume clicked, we're gonna resume player. So we're gonna set the time scale back to 1. That's that, and we already have listeners for our restart and main menu click, so we don't need to do that. So now we're gonna attach our methods to our buttons. So we're gonna go on list is empty on click. We're gonna go add that. We're gonna go over here in our scene. We're going to select our gameplay manager. There it is. And in the gameplay managers for functions, okay, I selected the wrong thing. I'm gonna drag and drop this. We're gonna gameplay manager, and then we go to on pause clicked. That's it. So on pause click, that function will be called and timescale will be 0. Now for a restart button. Oh, I missed one thing in pause click to enable the panel, so we'll do it quickly. So, but first let me just handle these listeners. On pause click, and we go back to here, gameplay manager, restart. On restart clicked, there we go. On main menu click, we add again gameplay manager, drag and drop. We go gameplay manager. On restart clicked, and then on pause panel for resume, we add this. Sorry, we add our gameplay manager, and we add this. We go to gameplay manager, we add on resume clicked, add on restart click, the same story. And then on main menu, the same story. Whoops. Oh, I don't want this as prefab. I'm gonna delete it. I want to add this there. I want to add this here, and then there. I want to go gameplay manager. On main menu, clicked. So that should be fine. You go back here. I forgot to disable and enable the pause panel. And when we are clicking on pause, hey, what's happening? Why can't I? Oh my god, I hate Siri. Sorry, it's not Siri, it's Cortana. I suck. Anyways, pause panel. I'm losing my voice now. Pause panel, or maybe I lost it a lot, like long before. Pause panel. And damn, how these streamers keep this up. Set active to true. And then on resume clicked. Pause panel. Set active to false. And we should be Gucci. So just to display how it works, I'm gonna go click play. Click on pause. Okay, nothing happens. I guess I forgot to yeah, I did forgot to assign pause panel. So I'm just gonna quickly do that, and I'm gonna click play now. I'm gonna click on pause to see if it pauses. I click on pause. It shows us our resume restart main menu text. Click on resume. It resumes the game. I can move about now. I click on pause again. I click on restart. It restarts my game, so it's working fine. Let me see if it spawns everything. It does. If I click on pause again, if I click on main menu, it will take me to main menu. There we go. We are at our main menu. If you quit from your Android device, it won't do anything. So just keep in mind that it won't do anything. And if you're running from debugger mode, or if you're just clicking play on editor. Alright, so this pretty much is our gameplay for now. Pretty good, pretty simple, pretty sleek. With pause, with everything in there, place in there. Now what we're going to do is we're just gonna quickly add Unity ads to it. So for Unity ads, you want to go in your services, and you want to enable your ads. You can just continue, and there we go. Ads are not enabled. Ads are not enabled. I repeat, ads are not enabled. So you basically make your Unity ad. You go to your dashboard. So now the ads are enabled. You go to your dashboard. You go to your projects, you click you should show right here. It's not showing, so that's something new to me. So anyways, essentially you go to your project, you create, I'm gonna just check if it's actually linked or not. It should be linked. My ads are on. Age designation settings. And then I'll like project. And then link it again. Dev team, that's basically my company name. I'm gonna create a new one. Now let me see if it's there now. Okay, now it's there, so now you can see minimal run. Turn on operate. Enable ads. So now once the ads are enabled, you have to go to your monetization. You gotta create placements. Sorry, you gotta create platforms. You get your game ID, you get your stuff from here, and you can just quickly go to your game ID. It selects your ad settings and stuff. You can go to your placements. It gives you a few default placements. So I'm just gonna go ahead and use a default placement I have for me. And I am gonna change my game ID. So I'm gonna create a new project and link it to this one so I can change my game ID. So I'm gonna go ahead and hide my screen over here. Okay, fine. So I'll just quickly link it to a different project and later on, and then we're good to go. I'll do it later, I won't do it now. So anyway, so once you're done, once you have done that, you're good to get Unity ads. So I'm gonna go ahead and pull up an old project of mine, which I did for Unity ads check, and I'm gonna get that, and we're gonna add Unity ads to our product. Not here. Scripts. Unity ad. So I'm just gonna go ahead and copy and paste this and change whatever is required for me. I'm gonna create a new script for Unity ad. gonna copy my old script to it. I'm going to change some, remove some stuff. This is me just removing some stuff that's not required anymore. So what we're gonna do is after the game's over, we're gonna show an ad. So I don't need these stuff. So we're not gonna do it in every game over. We're just gonna do it like once every 2 games. I'm just gonna go ahead and copy my game ID. I wanna go in there. Three 3871. So we have our so to show an ad in Unity, what you have to do is first you need to enable your ads like we did, and then you need to import Unity Engine advertisements package. You need to on awake. Basically, awake is function which is called as soon as the game object is instantiated, before even the start function. So anyways, I hope I'm correct, but you should double check that. So anyways, advertisements.initialize. This will basically initialize your game for Unity ad, and then you want to basically want to show an ad. This, ignore this. This is just something I did for my own stuff. So show rewarded ad, I have this function which basically checks if the advertisement is ready, the game over ad is ready. But we show the game over ad, and we also set a result callback to our function. So whenever the ad is completed, or it's failed to load and stuff like that, it's skipped, this handle show result will be called. So we choose that as an option and we show it. So in our handle show results function, we take in the show result, we check if the result was finished. If you want to reward the player, you can reward the player here. If they skip, you can do whatever you want to do when the player skips. If the ad fails, I basically retry max number of times, and if it still fails, I do the game over. So what we're going to do is after every, say, third or fourth second, after every second game over, we are going to show the ad to player. So when the game's running, we are going to count how many times the game is played. So we have an int game played counter, which will be starting from 0. And whenever start game is called, we do it plus equal to 1. So we basically increase it by 1. Or whenever restart game is called, We increase it by 1. And we make this public. And in our gameplay manager, game over. After we have shown our gameplay panel, we check if our game manager, we check if our gameplay counter is divisible by 2. The gameplay counter is completely divisible by 2, so mod gives you reminder of division. So if the remainder of the division is 0, that means it's divisible by 2. That means it's either 2, 4, 6, 8, and so on. If that's the case, we want to show a Unity add. And to do that, what we can do is go back to our game manager. We can add our Unity add component to it. So basically we are adding the Unity add script to it. And what we do is I guess that would be better. We get our game manager first. And then we, instead of getting instance over here again, we just use game manager. And in game manager.get component, Unity add dot show rewarded add. And since I'm just gonna go here and remove the rewarded for parameter. Here it's gonna cause an error or something. I'm gonna remove this over here as well. And we're gonna remove this from here. So since we don't care about what we want to reward player, we want to reward player by, say, in another second chance, where they continue from there on. So we can do stuff like that from here. But we're gonna skip this step. I mean, you can pretty much figure it out on your own now, since you have made it this far anyways. So another thing which I need to change is, since in my placements over here we have rewarded video, so instead of game over that, I'm gonna change it to rewarded video, and I'm gonna change it everywhere. So now when I play my game, if I die 2 times, I see the ad. So let's just see it works. Not. I need to enable this from here as well. Let me go back, come back here. Enable this. Okay, let's go now. Oh, I need to enable the test mode. So I'll have to die 2 times, so just be patient about this, please. Because spawning of -1 life is starting now. Okay, so I see the screen because the gameplay counter is 0, and 2 mod 0, 2 remainder 0 is 0. So that's why the screen. But if you see the screen, essentially that means that you have implemented everything correctly with Unity add, and when you will build the game, when you will build an APK, you will see a proper test video ad for this. And when you disable test mode, you'll see a proper full commercial ad. You can go ahead and close this, and basically that would mean that the video was completed and you saw the video. So if I restart it and if I play it again, you'll see that I won't see ads, because now the gameplay counter is 1. So it won't show me any ad because 1 is not divisible by 2. So see, I don't see any ads, and I'm gonna go ahead and click on main menu. So I guess I clicked on resume by that mistake. If I die again, I'll see an ad, because that's basically now the gameplay counter becomes 2. And I see an ad. So yeah, it's working fine. So for some reason my main menu is going to restart. So I'll just check if it's linked correctly. In my game over panel, the main menu button and the inspector. Okay, it's linked to on restart clicked. We need to change it to on main menu clicked. Is on restart click correct? It's correct. So this makes everything ready up now for your commercial game. We just need to change the main menu stuff and make sure that a user is able to navigate from here as well. So for that, we're just going to make it pretty simple. We're going to add the script over here and on our canvas. We're gonna name it button listener menu button listener. I'm gonna add the new script, and you can copy it in our, what's this doing here? Go inside gameplay. Go inside main menu. Oh god, I need to go to work in like an hour. So now it's at our main menu. I go here, go to main menu, and over here I made 2 functions. I'm gonna delete these. It's always good practice to delete update call function calls, because it's gonna call a blank function anyways if you leave it that way. So it's a good practice that whenever you don't need it, you delete it from the script. Hey, what's going on? Public void on play clicked. We're gonna go game manager dot get instance dot start game. So now start game will go 1 as soon as you hit play game. Public void on delete. Oh, sorry. On quit clicked. Game manager. Sorry, not game manager. Application dot quit. So this will make sure that you quit the game. Otherwise, the quit button will just do nothing. So that's pretty much it for main menu scene. If I go play over here. So one thing, you don't need to always pick up your Android device. With buttons and stuff, you can navigate with mouse as well. So like if I click play, oh, I forgot to hook up the buttons. With my listeners, I'm gonna do it wrong. Canvas, main menu, button listener, on play clicked, quit. Canvas, we get canvas. Main menu by listener and on click clicked. Play, click play. We can now play the game. We go, okay, I want to go back. Go main menu. Hey, I want to play again. Hey, I want to restart. Hey, I want to resume. Nope, I want to go main menu. I want to quit. You quit. So quit doesn't quit the application now as well, because I mean we are playing from the editor, but in Android device this will quit the application now. Okay, so that was that, and another thing is left is the save manager. So we can discuss that as well. We're gonna quickly create a new folder, and I'm gonna click it saves data. And what we're going to do is I'm gonna copy some stuff from my other project. Essentially, I'll get these scripts, save manager and user data. I'm gonna keep it very simple for us, so we don't get lost everywhere, and quick as fuck. So I'm gonna go back here, go to save data, go to user data. So okay, so what this user data is that it's a script. It's not a script basically. It's just a simple object which I want to store in memory forever once the user installs the game. So I have defined a couple of stuff over here which basically user can set. User was able to navigate through in my game. And one thing it says that it's missing newtonsoft.json. It's basically an asset I use. So I'm to convert say this whole product object into JSON. So it will be like chosen theme colon name of chosen theme, music enabled colon false or true, high score colon the user's high score and stuff like that. So what we're gonna do is I'm gonna get rid of all of this, since we only need to store high score, and I'm gonna click on save. Gonna import the asset store for Newtonsoft JSON. I recommend using this, guys, because this handles a lot of stuff like JSON inside JSON and stuff like that. So it's a good practice to use this one. It's this one, JSON.NET for Unity. Just get this one. Just gonna import it and then compile the scripts. Am I dropping frames? No, I'm not. Okay, so now, because you can see the error is gone. So basically this serialize function, what this basically means is that it will convert this whole user data into a string. That string can be an XML file or a JSON file. An XML file will be like this, like high score 999 and high score, and a JSON file would be like this. Okay, say high score colon 999. So that's basically it. So this will convert into JSON. So that's this one, the one I'm selecting. So I'm gonna remove this, everything. Okay, so this is what you need for saving your user data. Another thing which you need is the save manager which I made. So again, Save Manager is again a static app, which static object, which I make sure stays alive between my scenes, because let's just say if user changes the settings or buys something from shop, and then goes to play a game and makes a high score. So you need it in a different scenes. So I make sure that it's on don't destroy and reload. I'm gonna remove these errors because I copied it from somewhere else. So we have these errors. I'm just gonna remove all these error stuff. So the helper script I copied is basically just a script which can encrypt and decrypt my JSON file. Well, I encrypted because I don't want, users to say change stuff, like hack my app or do something which they're not supposed to with it. So I just encrypt it. So if it's encrypted, they cannot see it, they cannot modify it. So that's why you should also encrypt or decrypt it. I'm not gonna show you guys that function because I've been using that script in my other games. So it has the key in it. So I'm not gonna show you that, but it should be pretty easy find anyways. So in case you're wondering what's the bunch of stuff I deleted, I am just deleting it. The Google Play Games services save system, I'm just deleting that stuff. I'm just going to keep the user data to make sure that I am able to save it in a local user's device itself. I don't need to save it on cloud. So what we're going to do is when user plays a game, we are going to see if its high score is greater than what they made previously, and if yes, then we're going to save it, and then we're going to use to display it as well. So what I do is so the starting point for the game for me is a main menu. So I tend to have start method and get my methods over here, get the save manager initialized over here. I need some sleep actually. Save manager load user data. So in case you're wondering what this load user data function does, I'm gonna quickly go through it. So the load user data is simply checking player preferences. Player preferences what Unity uses to store data. So what we do is we make a key user data and we give it a value. So as you can see, if we go to our save user data, you can see we encrypt our user data and we get the JSON string from that method, and then we set the user data key in our player preferences to our data. So this user data becomes equal to data. So it's essentially just making another variable called user data and assigning our string, JSON string of user data to it, which is obviously encrypted. So we get the JSON over here, we encrypt it, we get the string, we create a user data variable, and we assign the value of our encrypted string to it. When we load user data, we check if the player preferences has a variable named user data. If yes, we get the user data string and we decrypt it, and then we deserialize it. That means we convert the JSON into user data object, and then we assign the user data of save manager to it. If not, then we create a new user data and we set the high score to 0. That means if the user data variable is not there, that means the user is running the game first time. So we just create a new save game and just assign the value to it. So for the first time in running, what will happen is we will create a new save game and the high score will be 0. Now in our gameplay manager, where is it? In our gameplay manager, when the game is over, what we're going to do is we're going to get our save manager. We're gonna set the user data. We are going to check if if the user data of the current save we have loaded high score is greater than is less than current score, then we can update the score. That means if this current score is greater than high score, we need to update the score. So how do we do it is we call the save manager user data high score equal to score, and then we just simply call the save manager dot save user data. So just to recall, save user data will take the user data, get the JSON string, encrypt it, and save it in a user data variables in their preferences. One thing we're going to do is we're going to do this as the first thing in our game over, and we're going, since we're already checking over here that if the score is greater than current score, and we have already updated the high score over here, we can set the personal best text to something like this. And you can go a bit more crazy with it, like you can have it like new personal best over here, and over here we can have it like, so if our score is greater than our highest score we made, we'll show new personal best. If not, we'll just show personal best. So let's just see if it works. There are errors. Save manager. There is one error in save manager. Oh, this one. Another cloud stuff. So just a quick recap. We'll do a quick recap after we see if it's working or not. So I'm going to click on play. We are now playing the game. I scored 200, so I'm just going to score 200 and avoid everything else. I'm gonna get the -1. Another -1 and another -1. So now we die, and as you can see, we see our current score was 700 and we had a new personal best of 700. If I restart the game and I play more, so I'm gonna beat my 700 now. Okay, so what happened over here is, I'll show you on the screen. What happened over here is the game just detected my score correctly, and the score was too long to display. So in my panel, if you come to game over text, if you come to personal best text, you can see that new personal best 1100. So to fix this, what we can do is we can just make sure that um, we can either make the font size small, or we can display it in the new line, the score in the new line. We can do that. So I'm gonna go ahead and display score in new line. Where is the gameplay manager? New personal best backslash and so far the new line. And over here I'm gonna load up my gameplay manager gameplay scene to edit, to make sure that it will work correctly. Gameplay manager, canvas, in my game over scene, in my new personal best. Let's say if I write new personal best colon, and I print a new line 1100. So I need to increase the size of it a bit. That's all. That's all there's to it. So for new personal best, you get the score in new line. If your current score, you get there. Maybe I could make this as well a bit more beautiful, but I'm gonna keep it this way. And also, we'll just check if it's working. So we're going to go back to our main menu scene to make sure that when we run the game, it loads the data, because the data loading happens in main menu scene. So in main menu scene, we click on play. I forgot to disable the game over panel. Disable it. Save the scene. Go back to main menu. Click play. And click play on the screen. Wait to die. It's not gonna collect anything at all. And you can see it's the personal best still remains with us, even if we closed the game and came back. So that's how you can save a game to on your phone or on user's phone. To save it on cloud, I'll probably have it in another tutorial, because that's a bit of a process. Because Google, you gotta go for Google, you gotta have a whole play game script, which will take time explaining because it has a lot of stuff to it. So I'm gonna keep it in another tutorial, and I think I beat my challenge. How long have I been streaming for? 4 hours, 30 minutes, and I made a whole new game with it with almost no bugs at all. I mean, there will be bugs, but they're not at least too visible with a very bad UI though. But yeah, we can discount that for now. And maybe another thing which I could show you would be particle effects a little bit. So I'm just gonna add particles coming down. So what we're gonna do is we're gonna add a effects particle system, and it added this to canvas. That's not nice. And we need this in our game. Okay, so what I'll do is I'll make it look like there are particles coming down and you're running up. So I'll go ahead and keep the particle over here and rotate it to 90 degrees. Not Y. Is it Z? Not Z. So I gotta rotate this to 90 and keep this a bit up. If you see my game, you see how it looks like the game. So it looks like this. So it's giving a kind of an effect where you're moving up more, and you can change a lot of stuff over here. So first thing, we're going to change this into it's emitting like a cone-ish area. We would be better if it's either a regular cone or something like that. So what we're going to do is we're going to change the cone and we can make it a rectangle, and so now it's emitting in one line. And in rectangle, what can we change is the scale of it. So we can basically make it scale of 6, and now you can see it's more uniform now, and just emitting, going down, 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 and down. We can change the start lifetime of it. So each particle lasts 2 seconds. But we will want that. We want that more. So we will make it like 5. 5 was seeming pretty good. I guess we can make it 3. 3 seems. How does 3 do? We can change the start speed of it. We can change the start speed to 2. I'm gonna keep the lifetime. If we change the start speed, we need to change lifetime to 8. 8 should be better. So now you can see it looks like this. So a lot of particles slowly falling down, down, and down, and down, and down, and down, and down. And we can change this with our with our what do we call it, with our script as well. I'm gonna keep it to 400, or maybe 20. Okay, 20 is not good. 100. Wait, we can keep it to 50, and in emissions we'll decrease the spawn rate to say 5 over time. Maybe we could do it more 3 over time. So now it looks like this. So not too many particles, few particles just coming down. If we do it 2 over lifetime, we get a little more particles and stuff like that. Yeah, so that's the particle system, and we'll increase it with our difficulty. So we go ahead, go to our object spawner, and we keep a public game object particle we wait to compile. We add our particle system to it. You save it. Now save it each time the difficulty increases. I will increase the speed of the particles, the search speed. So what we're going to do is we're going to, in our increase difficulty, say if we are decreasing the spawn interval, we do particles dot get component particle system then we change the start speed of it. Actually it's deprecated, so I'd better show you a better way. We click on dot main module and we assign it to particle system dot main module main equal to this. Then we get main dot start speed plus equal to 0.2. Okay, so one thing which we need to do is particle system dot particle system dot min max curve 0.2. There is a way to do it. I'm not remembering it. I did it just now. I'm trying to remember where did I did it, so we can just get that thing from there. Because I completely forgot. I mean, I just did it today morning. Maybe maybe I did it in object spawner. Anyways, I might just Google search it. It would be better that way. Go over here, particle system name, start speed, constant. So this is useless, so we're gonna go back and we're gonna get some people's answers. I guess we gotta do this way. So what we're going to do is we're going to get the original lifetime first. Float original speed equal to main dot start speed constant and dot constant equal to, okay, I'm gonna hit the constant, and how did he set it? Unity min max curve constant. And I mean, I completely forgot it. Unity set start speed of main dot start speed dot constant. Is it only a get flag? Original speed plus 0.2 f. I really need to Google this. So we could do this way. me see this particle system dot min max curve min max curve start speed equal to this, and then start speed dot constant equal to original speed plus equal to 0.2 and yeah, so this is the way we can do it. Anyways, so now it will increase to 1.4 times the speed. We can change it to 0.5 if we wish to. So we're just going to quickly see if the speeds increase or not. I'm going to keep it in particle system. We should see the changes over here after every 5 seconds or so. Okay, there are literally nothing's happening, nothing's spawning. Oh, I need to hit play. I'm down. So I guess the start speed is not increasing. Oh, wait, I made a mistake. Particles dot get component particle system dot main I don't need this, I guess. I'm just gonna check the debug.log over here. And to check that it's changing or not. We are going to add a statement over here which gets me the speed. This will show us if the value is actually changing or not. So now we just check it once. If it works, Gucci. If it's not, I'm gonna sleep. So it's not increasing, and obviously we are missing something in our increased difficulty because difficulty increases to completely max. We are missing some simple stuff. Next increase time equal to time plus increase difficulty interval. That's that, and we're still not able to get around the start speed change. And because I am a dummy, you go here, where main dot start speed equal to new particle system dot min max curve. We have a float constant over here. I remember now I did it this way. And let's just check if this works now. So I'm just gonna keep it this way so we can just see the differences there. In UI with the start speed to maxed up. We gotta wait 5 seconds for 3, 2, 1. So yeah, there is definitely change in our particles. They are actually too fast. So anyway, we finally got around with an issue where we were not able to increase the start speed of it, but now we are able to. Just need to check one more thing. Is max difficulty error being set to false? And I'm gonna remove the debug.logs from here. Gonna hit play. It's false till now. Still false, still false, still false. So max difficulty is not being set to true ever. That's an issue because it should be set to true at some point. So why? Because one of these conditions are failing. So to fix this, what I'm gonna do is I'm gonna go here, make this as an integer. Might be some small issue of float precision numbers because everything in my code is pretty much correct. Now we don't need to typecast it like this. So obstacle spawn chance keeps increasing till it reaches the max. This decreases. Hey, where's the spawn interval decrease go? Oh, that's way. Spawn interval. Minus equal to 0.2f. That's what we did, or we did 1.2? We did 0.2, right? We did 0.2. Now it should be there. Yeah, so now it's coming true. Yeah, so we are good to go. We might want to decrease the speed of it to say 0.1. And that's all we gotta do. So that's it, pretty much our first game. Particle systems are pretty cool. You can make cool explosions from it. And there is this Unity particle pack already there, which has already very cool effects like explosion, smoke, and stuff like that. You might want to try that from Asset Store. I'm just going to quickly go ahead and search for you. You might want to go for Unity Particle Pack 5.x, and you are pretty good to go. So this was our first game in one night challenge. I mean, just more like a personal challenge. We'll put this game on Play Store soon after I change the game ID and stuff for the ads. And I guess that's pretty much it for today. Thanks everyone for joining me. And also I'll be uploading this to YouTube, so you can find it there as well if anyone's looking for it. Thanks everybody. I'm gonna end the stream here, and I hope you guys have a good day or good night, whatever. Take care. Bye bye.